from Massachusetts. He's going to park the car, he's going to party, and he's going to take it away. Okay? So Dave, it's a pleasure having you back.
I put together a it's basically, I put a 32-hour class together for misfires. I was asked to write a misfire class, and I don't believe you can do a class literally in 4, 6, 8 hours. You got to cover too much. What I want to do is, I'm a mobile tech, and I go to shops, and when I go to shops, the cars have either been there for 2 or 3 days, or the car's been back over and over and over again. So basically I do is I go in there and I'm looking for a new diagnostic direction, and that's all I'm there for. Misfires. We're going to do is, I put diagnostic sheets together about 3 or 4 years ago, and I pass them out to the guys. And when I teach classes, a lot of times after I teach a class, I'll get like 1,400 emails, and Rick usually gets rid of them all for me. But I'll teach a class, and I'll say to the guys, hey, look, if you didn't understand any of the material, please call me. Please call me, email me, whatnot, and I'll get back to you. Even though we got to cover the whole class, I'll do it again. I just want to make sure you get everything out of the class. But everybody called me back, and the emails were always about cars broken down, misfires, and whatnot. So I finally put together these misfire sheets, which you got in your book, and I want you guys to follow them. I'm going to make suggestions, but a lot of times when I go to a shop, the car will be there for 2 or 3 days, and these are quality shops. These guys are trained like you guys. They go to school, they go whatnot, but we tend to jump around. We tend not to go after the basics, and I'll show up at a shop, and I won't get through the second sheet, and I'm done. So I'm saying to myself, I don't know what took 2 days. I don't know what took 3 days. So the whole idea was, when I was asked to write this class, was this. If you take 8 hours to fix a car, I want to knock it down to 4. If you got 4 hours in the diagnostic, I want to knock it down to 2. The whole idea of this class is just to help you knock some of the time down. And that's basically all I want to do. I had to figure out a way to, G gave me 3.5 hours, and I gave him 300 slides. So we're going to crank through a lot of the stuff in the beginning. I want to get to the case studies. I want to cover some stuff that we really need to know as far as just going in and diagnosing the car. A lot of the information you already know, but there's a lot of information that even though we knew how to do, or learned in high school, we learned when we went to college or whatnot, we're just not applying it every day. We really need to. I don't care if the car's got VVT, I don't care if the car's got GDI, I don't care if the car's turbocharged, I don't care about any of that stuff. That stuff to me is just add-on. The thing I concentrate is the combustion process. That's the only thing I want you guys to consider, is the combustion process. I don't care about what else is bolted onto that car. I keep everything as simple as possible. So again, we're going to crank through a few of these things. I want to get to the case studies. If I go a little too fast, please slow me down a little. But again, I got enough material for 8 hours, and I kind of wish I had 8 hours. First thing is, what is a misfire? A physical problem located inside the cylinder that is affecting the combustion process, or a physical problem located outside the cylinder that is affecting the combustion process. Again, the combustion process is the big word here. Lack of crankshaft acceleration on a cylinder's power stroke, or the crankshaft intermittently slows down more than normal. Now, a PCM interpreted misfire, and we'll get a little bit more into that. But, I mean, which one of these is right? They're all right? But that's not, my definition for this is this. It's a task that can consume large amounts of shop time and provide you with the least amount of profit for time spent. It's true. I always say that anybody can fix a car, but it's the diagnostic or diagnosing the car that'll kill you. I mean, to find out an intermittent problem and it's a module, how long will it take you to change the module? But if it's an intermittent problem, can you have 4 or 5 hours into the car? You can. Dollar bill. I still do this, and I grabbed the 20 one day. I finally got smart. I go in, I'm an old geezer, and I go into the shops and I go to the guys. I don't physically work on the cars. I will, I back probe the stuff, but I don't physically touch the cars. So I'll say to the guy, I always go over and even to this day, and I check the tailpipe, and I always put a dollar bill and see if it sucks in. I still do it to this day. So I say to the kid, I'm going to teach him, and I go, hey, go get $1 from your boss. So I did that for the longest time. And I go, you know, you got to work smart and work less as you get older in years because you can't keep up. So then I smarten up. I go, hey, dude, go get 20 bucks from the boss. So every time I tell the guy to get a $1 bill, now I get 20. Oh, I keep the 20. It's a lesson. And, you know, by the end of the week, it's like an extra 120 bucks. And it works out pretty good. But why does the $1 bill get drawn back in? Why does it gets drawn back in? Because what? There's a pressure change, but we have a compression stroke, and then do we have a what? Do we have a power stroke? No, we have a decompression stroke. So after we start building it up from 90 degrees to top dead center, we take those air and fuel molecules and we compress them. I'm just going to lower this down. We compress them, and they're very elastic. So we compress it, and then because we have no combustion process, they just expand again. Once it gets down past 90 degrees again, a little bit further, now we're back down to basically where it was before we compress it. But the piston's still going down because about 40, as you guys know, 30 to 45 degrees before bottom dead center, what's going to happen? The exhaust valve is going to open. So from the point where it got to about 100, 120 degrees, or 100 degrees, or 90 to 100 degrees, and it starts pulling down, the piston's pulling against what? Two closed valves, right? So we're actually drawing a vacuum in the cylinder. It's a pressure differential. So we're drawing a vacuum in the cylinder. So when that valve opens up, what do we got for pressure in the exhaust? Yeah, well, positive pressure is going to go right back into the negative pressure. And that's what we got. So I still do this, and I'll be honest with you. When I say PCM detected, a PCM can detect an actual misfire, but there's a lot of times you go up to a car, which we're going to cover, and guys will come up to me and say, Dave, the light's flashing. It's flashing like crazy. I can put a cup on it, and the cup won't even move. I do everything. I kill the cylinders. I do everything in that car, and that cylinder is not misfiring. And it's not. It's not physically misfiring. A lot of times when the PCM detected, the first thing I'll say to the guy, dude, is getting vibration. Because if you have a vibration, I go down the street and you can have AC compressor. You can have, I used to do Volkswagen Audis. I don't like to brag about it, but I worked on those things for 23 years. I still get cold chills every once in a while when I have to work on one. But we used to have the inner CV joints, and we would get them brand new out of the factory, and they'd literally be frozen. I mean, we used to pack them with grease, and you had to put them on a vise just to turn them a little. So when we started going after misfires in '96, you know, people would bring the cars in, and I'd come in and they go, we got to tow it in, can't go any further. And I'll put the car up in the air, we push it in, and the output shaft and that little stub shaft is ripped right off the transmission. And I'll turn around and I'll say to the guy, I'll come out and I go, did you hear? First you saw, was there a flashing light? Yeah, I was waiting for something else. Okay, and then what was something else? Well, it was a real loud vibration. Why don't you bring it down? I was waiting for something else. Well, then he waited for the tow truck. So a CV joint, a harmonic balancer, a lot of the Ford has a big problem right now with the harmonic balancers on the 4 liters from 2004 to 2007. We're having a lot of problems with the balancers. Those balancers will go, the keyways let go on those things, and the balancer goes back and forth. And what we're actually doing is when we step on the gas, we're shifting the balancer one way, and we let off, it's coming back. It's coming back. So, and the reluctor wheel is actually attached to it. So when I step on the gas, I'll have one common cylinder, but I'll have two, I'll get, like say, 3 misfire all the time. I'll get 3, 5, and 6, and then when I decel, I'll get 3, 1, and 2. And if the PCM is looking, it's counting. The PCM is actually counting the crank angles. It knows the speed between the sensor, between each one of the pulses, and it's comparing it to something. So right now, what I'm doing is when I step on the gas, so if I get a misfire, a lot of times the guys will call me up and I'll say, dude, when you take it for a ride, does it have a vibration? If it has a vibration, you need to chase the vibration. You need to chase the vibration. Okay. If a defective belt tensioner pulley can prevent an engine from rotating, can it create an engine misfire as it's failing? It can. The belts themselves. How about a malfunction AC compressor? When the reed valves, we bring pressure at both sides. Now, will either one of these be a specific cylinder misfire, or it's going to be a random? They're going to be random. And that's what how about a frozen U-joint or a frozen inner CV joint? I have a guy that I work with for a long time. He does American cars, and I always did foreign. So when I got out, I decided I wasn't going to do Volkswagen, Audis, BMW. I was going to try something else. So I started working on the American cars. But I never saw drive shafts in my world. I don't know what a drive shaft was. And they got all these CV and all 3 or 4 joints on it. So I got to call up. He got a Ranger. He got 2000, I think it was 2001 Ranger. It's got a 4-cylinder. It's got 8 spark plugs on it. So he goes, Dave, I got a misfire. Drive down the street, I get misfires from every cylinder. He says, we want you to program the PCM. So I go down, I show up, and I go, well, you know I'm not going to program the PCM without checking out the car. He goes, Dave, we put 2 coils, we put 8 spark plugs on it, we put 8 set of wires, we did this. You step on the gas, and he goes, so I go, okay, let's take it for a ride. So he puts the scanner on it, and we're driving down the street, and the car's vibrating. The faster I go, the more it's vibrating. It's getting to a point about 60 miles an hour. I'm waiting for the windshield to just lay on the hood. So he's looking at the scan tool. He goes, look at it. Look at the scan tool. I go, I'm holding on to the car like this. I go, my teeth are loose. I'm going like this. My pants are falling down. And so I turn around. I go, Smitty. Well, you guys don't know him. So I go, hey, Smitty, you don't feel that? He goes, no, they don't. That's probably the rear tires. You don't care about that. We care about the misfire. So I bring it back and I say, Smitty, we're going to go after the vibration. It ain't the tires. So I have him take the U-joint off the back. And I said, one of those U-joints are frozen. And he says, so he takes the U-joint off the back and he takes the drive shaft and he goes up and down like this and he goes, you're wrong. I told you it was the tires. So I go, Smitty, turn the drive shaft. So he turns the drive shaft and I reach up and I grab it and I can take my feet off the ground. It takes about a second or 2 before the drive shaft comes down. So I go, Smitty, I said, put U-joints in. I'm not going to do the PCM. I'll be back in a couple hours. I come back in a couple hours. We take the car for a ride. He goes, my boss is still confused why you're doing the U-joint. So we're driving down the street. He goes, hey. He goes, look at the misfires. They're not counting anymore. I go, Smitty, don't you feel that? No, the customer don't care about. I go, there's no vibration anymore. He goes, no, I don't care about that. He goes, look at the scan tool. It ain't counting up anymore. And I was like, oh my God. That's what I figured that's all American mechanics are like that. You know what I mean? Okay. Can a lack of maintenance create a cylinder misfire? Big time, especially with VVT. How about the early VTECs for the Honda? Guys are still chasing that to this day. We have, when it goes on the high cam, if that screen gets plugged, there's only so much time, but that pressure switch has to change state. And that's the feedback going back to the computer. If it doesn't change state quick enough, but does change state, say it takes a minute to change state. After a minute, it's going to set the light on. When it sets the light on, then it'll set a DTC, you'll know where to go. But up to that point before it sets the light, what's it going to do? It's going to shut injectors off. So driving down the street, and they got a 4-cylinder car, and they try to go 48, 4,900 miles up, 5,000 RPMs, and then that screen is blocked, and then all of a sudden you're cutting off injectors. And that's been like that for 10 years. Probably 12 years now. And the thing with me is every time I get a Honda, I always get a VVT code. And it reminds me, I'm an old geezer, so it reminds me of the old Dodge Darts. Remember the Dodge Darts? Does this? They come in. No, all 5 quarts of oil missing. Rapping like crazy. You fill 5 quarts of oil, and the car's fine for another 100,000 miles. So the Honda comes in, it's got a half a quart of oil. I put 3.5 more in, and then the VVT, the code's gone. That's a pretty good way to clean the screen, I guess. Can cylinder misfires be created by driving a vehicle with low levels of fuel in the tank? Most of the cars right now, if you try to read the document for the EPA and stuff, it's about, the last time I looked it up, it was about 68 pages. And it'll go 1.001, 1.002. You'll get up to like 36.661. And it probably is, it's hard to watch it because it keeps going back and forth, back and forth. So when I wrote this class, I talked to one of my friends, he's called Mike McCarthy. He works for the California Air Resource Board. And I said, Mike, there's a lot of gray areas with the misfire monitors, and we were going back and forth. And I go, it doesn't specifically say that a Ford at a quarter of a tank is going to shut the misfire monitor off. My advice is this. Don't take these cars for a ride. Don't go look for misfires if you don't have at least a quarter of a tank for gas. Because I want you to drive the car like you don't own it. All right? And the thing is this. You start taking a car for a ride. I don't know why they drop them off with drivability problems, but most of them got a 16th of a tank, 8th of a tank. What are you supposed to do with that? You can't even get one good hole shot out of that one. But, so the thing is this. If we take the car and we're able to lean out the mixture, We're chasing a misfire that the PCM may not even be detecting. So it's a total waste of time. So my point is this: if we get a low tank of gas and we're creating misfires, does the ECM, PCM, or VCM even detect these misfires on late model cars? They don't. On your diagnostic sheets, it says make, model, and right next to that says fuel level. If it doesn't have a quarter of a tank, don't bother with the car. You got to put gas in it. Two words I want to concentrate on during the class when diagnosing a misfire. Again, combustion process. That's all I want you to think about. Anything that negatively affects the combustion process can create a misfire. With a normal combustion process occurring, the power stroke pushes on the crankshaft and accelerates it. Then the crankshaft coasts until the next power stroke occurs in the firing order. If there's a cylinder with incomplete combustion occurring, then the crankshaft that was coasting is going to slow down. It's going to slow down. When it reaches the threshold, it's going to set a DTC. It's going to set a DTC. So on a normal car, you're going to see a few of these. I got a bunch of scan tools. I'm going to use the factory ones if they show the best as far as teaching aid. I'm going to use them. So don't think that this class is just all about factory tools. It's not. But you can see on a Ford IDS, this is software. This is not really a power balance. It's looking at crankshaft variations. But you can see on a normal car, at a normal good running engine, no misfires, we get a fluctuating about 25 RPMs, constantly fluctuating back and forth. That's the crank speeding up, slow, coasting, speeding up, coasting, speeding up, coasting. Now, if we do have a misfire, and that's a single cylinder misfire, it will drop, it will change the speed. If we can consider that accurate, we're looking at about a 50 RPM change. And the PCM will pick that right up. Incomplete combustion. I like to think of it as the 3 L's. A lack of combustion, a low combustion, and a late combustion. What would be a lack of combustion? Come on, loud. Okay, fuel spark. How about low combustion? Air, fuel, density, right? Low. How about late? First thing I think of late, I think is recessed valves. We do is we ignite the fuel mixture. We're constantly igniting the fuel mixture. We want the maximum combustion, or the ideal combustion, to happen around 40, 50 degrees after top dead center. So we're going to constantly adjust the ignition timing based on RPM and load, so we get that. Now, if we started at 40 degrees before top dead center, we ignite the mixture, and we have a recessed valve. Basically, the recessed valve is enclosing. So the gases are going back and forth. And it'll blow the flame up. And then if the motor's hot enough, the combustion itself is going to self-ignite at top dead center, right? We do timing so it doesn't self-ignite. So if it self-ignites at top dead center or just after, instead of 50 degrees, we want, for the maximum push, no more than 90 degrees after. All the push has to be done between 90 degrees after. If we end up doing the combustion, if we have the maximum combustion, when the piston is almost to the bottom, and we have huge volume between the bottom of the cylinder head and the piston, what kind of push are we going to get? Not much at all. And we know everything we're dealing with is recessed valves. Okay, I'm a big proponent of this. Crank sensors and trigger wheels and tone rings. This is a big thing for me. When I go to a car, we have a step. We're going to go through the whole thing. Customer survey, visual inspection. Visual inspection for me is a big thing. Then we're going to go into the charging system. We're going to go into relative compression. And then when I have you check the 4 primary circuits, I consider 4 primary circuits. It's crank cam, injector, and coil. If you got to understand, the crank sensor and the tone rings are a big thing. If the PCM cannot process that sensor, that signal correctly, to me that's garbage in. If the PCM can't determine what's going on, it's confused. How can it control the ignition and how can it control the injector? It can't. It can't. So, inside your book, I listed the Hall effect switch. I kept that on there only because I still see, I think with those, GM used those up to 2005, 2006 on the balances. I threw that in there. We're not going to cover any of it. I put all the descriptions in your book. Here's one of the test benches I have at home. I make the benches for when I do oscilloscope classes or SRS classes, but this is the most common one we're going to see is a gear tooth Hall effect sensor. We're not going to have anything as far as vanes anymore. The Hall effect switches or sensors, we're going to use a digital square wave. The biggest thing I want you to understand about this is this. We got a 10% boundary and a 90% boundary. We have to break those boundaries, reach them and break them for the PCM to be able to process the signal. Understand that. So if we have a crank sensor and we have a large air gap on it, and we can't make the signal, we can't break those boundaries, then the PCM is not going to be able to process that data correctly. And again, garbage in, garbage out. We call that the 90-10 engineering rule. Now, the OEMs will use the rising or the falling edge. They're going to pick a point that voltage has to reach and break a boundary. We don't know that. They're going to pick it for different cars, different make. They might go 50% on rising. They might be doing 50% on falling. We don't know where they're going to use it. But we just got to make sure that we can break that 10 and we can break the 90. Basically, everything we're doing in the car, all the tests that we're doing in the car, we're just breaking boundaries. That's all we're doing. We're breaking boundaries. Variable reluctance sensors. Again, AC sine wave. We know these things produce their own voltage. A lot of the cars, manufacturers out there, during cranking, they'll go 3/10 up, 3/10 down. Or they'll go half a volt up, half a volt down. When the car starts, then they'll go, if they want a half a volt, they'll drop down to 3. If they were 3/10 during cranking, 3/10 up, 3/10 down, then they'll go up to a half a volt, back and forth. Understand, we can have a beautiful signal, but if we don't get up to that 0.3, 300 millivolts up, or half a millivolts during cranking, can the PCM do anything with this? Absolutely not. Now, in your book, I do a lot of the body shops. I work on cars that are I only work back on 10-year-old cars. That's as far as I go. So every year I drop a car. This year I dropped the 2002s. Next year I'll drop the 2003s. I only work on the last 10-year-old cars. I get a lot of these cars, and it'll be like a 2012, 2011, and these cars all get smashed in the front. And I call my body shop guys magicians. I walk over the car, and I look at the car, and they got no hubcaps, no quarters, the hood's missing, the motor's on the ground, and I'm looking around trying to figure out what it is. And I'll go over to say, dude, what kind of car is this? And he goes, are you kidding? Look at the picture. The customer thinks it's going to look like this again. And I go, oh. But a lot of times, again, these signals, the PCM is using this rising or falling edge, and it's comparing it to something. It's clocking it against a cam against a crank. Now, it's doing the same thing with this. A lot of times, as you see in your book, there's a note under the crank sensors. And it says, important note, Kia, Honda, and Acura, and then some BMWs. Understand, I want you to do is, I want everybody using scopes. A lot of guys, when I go to a class, I teach a class, I'll ask them, I'll do an oscilloscope class, I'll go, how many guys got scopes? And about 3 guys raise their hand. And some of the class I teach is like 50, 55 guys. So maybe in a class that big, 8 guys raise their hand. Then I'm sitting there going, how many guys own a Modus? And 3/4 of the guys put their hands up. I go, guys, you got a great scope in there. Well, no, but it's a great scan tool. And I was like, no, it's a scope. You got to use the scope. And, well, the guy who sold us didn't know how to use it, so we don't use it. Now they're trading them in for the $10,000 tool. And I say the same thing. Dude, it's got a great scope in there. Bring it to class, we'll use the scope. No, I got it because it's got Bluetooth. And I can get on Identifix. And the refresh rate is so much faster and stuff. I go, for 10 grand? Are you seriously? I can buy like 4 or 5 scan tools. But the point is this. When I'm going to really push during the classes, I want you to start taking your scope out and getting all the relative compressions. I want you to do relative compressions. Crank and amperage test. I want you to do that. I want you to do cam and crank correlation. During the day, when you're working on any kind of drivability, especially misfires, you're going to be looking for this stuff. You might find it on IATN. People used to have it. But you got to create your own library. You got to create your own library. I'll go into now you know if that's got, first it's got a falling edge on it, okay? That's going to be a majority of them, like the Fords and whatnot. But understand, the car gets smashed in the front. The guy goes to put this back on. Can the wires get reversed? You can't believe what I had one, I chased it for about 4 days. I kept going, I go, dude, I'm missing something, And I'm looking, and then I finally turn around. They put a crank sensor in because they got crushed, and it was wound backwards. So I turn around, and I go, I'm looking, so I went back and I grabbed some of the waveforms, and I was showing up pretty, anyhow, it was a body shop, and I had to do some wiring stuff on the harness, and I went through and I says, hey, it's got a fallen edge, and I come back and I go, it's got a rising edge. Son of a gun. So I'm looking at it and I go, they waited a week for a crank sensor. I want to get paid, so I looked and I go, hey, dude, it's the next guy's problem. So what do? Just swap the wires. Let the next guy chase it. But understand, hey, it's by the hour, dude. It gets by the hour. And, I'm not greedy. Toyota? Does it go rising or falling? Do you remember? Can you, name a Toyota? Tacoma? Okay. Too old? Hey, listen, I'll be honest with you. Every once in a while, I get a history lesson. Dave, come on. I got this 96 Jeep. Are you kidding me? It's got a distributor in it. And Randy Dillman said 15 years ago, you don't put it on number one. You got to cut the old cap off. You got to move the rotor over. I was like, and I show up. I go, okay, let's look at the car. I go, it's misfiring like crazy. He goes, we got 2 distributors. We got 2 fuel pumps. We went with 2 crank sensors, and we got 2 PCMs. So we got all new parts in it. We got all the old parts in the trunk. And he goes, so you got plenty of parts to work with. And I had to figure out, it took me an hour to figure out how to sync the distributor. And it's like, forget it. I just don't need a history lesson. I get out of the dealership in 96. And, so everything from that point, I decided I'll do 2 cars. I'll do 3 cars. Now I do about 11 makes. And that's all I do. If I don't have the factory scan tool, I won't touch the car. That's just the way it is. But again, we have to break this boundary. I need you guys to start getting cam and crank correlations and putting them together, You're working on a car, you got your scope out, known good. If I turn around, instead of I drop this, if I have a falling edge, the PCM is now going to count over and it's expecting a rising or falling edge for the cam. If I turn around and I change that, is that out of sync right now? Some of them won't stop. Those are the ones I like. If it won't start, it's a done deal. Some of them just run lousy. Those are the ones that you got a problem. Okay, what is the approximate air gap between a crank sensor and a trigger wheel? 1 to 3,000. What symptoms occur if the air gap is fluctuating? Can the scan tool detect this occurrence? The scan tool cannot check that. And I'm going to be honest, we're going to cover scan tools real quick. I'm trying to get to the meat and the potatoes, which is the case studies. But can a malfunctioning crank sensor create a misfire? Yeah. The crank sensor is used in so many tests, so many algorithms that are run, and it's just so, RPM and load. It's involved in so many tests. How about a damaged trigger wheel? Would this be an actual misfire that you could feel, or just PCM detected? Most of them are going to be PCM detected. But understand, if I get a damaged flywheel, and all of a sudden, say it's a Chrysler, and I'm expecting to see 4 sine waves, and 4, or 4, and 5, and I get a damaged flywheel, and I increase the gap. So now, will I end up with 4 perfectly synced sine waves? No. I'll actually end up with 3. I could end up with 2. Because when it gets past the gap, it won't read it anymore. So it's going to get the first rising, and then when the flywheel is not dented and it comes back to its normal shape, I'm going to get the next falling edge. Now, if that's triggering, and I got a V6 and it's 1, 4, 2, 5, 3, 6, or whatever, can that shut down a set of cylinders? Yeah, it can. Okay, camshaft sensor input signal. So I'm a big thing is you got to go after this. You got to go after it. Now, some of the scopes, they'll have a little bit of noise on them. You put a filter, you clean it right up. Here the car comes in. and it's got a misfire. I get on it, bucks, 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 bucks. No code. Do you see anything? Blue is camshaft. Red is crankshaft. Let me get rid of the cam. Can that be a problem? Because now we know that the cam falls in between the spacing. So if we're going up the last falling edge and the first rise, or we're going up the first rise of the cam and the first or last of the falling edge of that sink, and that sink is wider than it should be, what do we just do? Okay, now here's another one. Okay, so now you got this one. I got a damaged flywheel. I see this all the time. I see this all the time. And the thing is this, it got two things. It got one or it got something else. What did it get? It got a motor or it got a tranny. And I'll turn around and I go, dude, you got to pull that tranny out. It needs a flywheel. So he comes over and you know, I can lift about 20 pounds right now, and that's all I can lift. And the guy comes over and he's dragging this pry bar. It's got a quarter, maybe a 1.5 inch square on it. And he lifts it up and he pops that tranny out. Well, they call that a flywheel. I don't call that a flywheel. I'm an old guy. You drop a flywheel on the ground, I'm going to break my foot and I'm going to chip the cement. If you rock the engine back and you sit on that, what's going to happen to that outer edge? It just flattens right out. Now look at this. Take a look at this. 2002 Jeep Grand Cherokee, same exact customer's complaint. You're driving down the street, it's bucking, it's misfiring. As the previous case study. Same exact problem. Here it is right here. Now we got 4, 4, 4, 4, and then we got a problem. So if it's a mechanical issue, we should see it occurring at each time, right? It'll be at the same spot every time. But what if it's like this? I got 4, 4, 4, 4, and I got it. Then I go on the next one. I got 4, 4, I have it. I have it again. I have it again. And then I got a long spot where it doesn't occur. Is that a flywheel? Air gap problem. It's an air gap problem, I agree. But is it a bent flywheel? It can't be. It can't be. This is one where they put a crank sensor in, and they end up changing 2 or 3 crank sensors because the aftermarket one's in such good quality shape that he got so tired he just tightened it by hand. So the customer's going down the street, towed off the highway, and she's going along, every imperfection in the road, the sensor's just going like this. And it was just cutting off random cylinders. Cutting off random cylinders. So is the air gap changing at the same point each time? It's not. Now, this one here, I tried to get all the parts. I just wasn't able to grab all the parts. But this is what I want to explain to you. I got 2 GM guys. They're really top-notch. They're great guys. But again, everybody gets taught a certain way. I worked in a dealer. You know, we went to school. We had to go to school every month and stuff. But they taught you flow charts, and they taught you to do things, right? And I was one of these guys, rebellious guys. I don't believe in flow charts. I just don't believe in flow charts. Because if it's 11 pages long, what am I going to do? Oh, it's either one of these 2 things, right? Forget about the first 10 pages. But my truck is full of equipment. I mean, I got a lot of money in equipment. I got to get rid of all that equipment. And what do I don't carry any tools. I don't carry no wrenches, nothing. And my truck is packed. What do I got to carry if I'm going to use a flow chart? I got to empty all the cabinets and fill it with what? Known good parts. Because after the 3rd step, if it don't work, put a known good part in. So I got to carry computers and modules. Oh, it's going to be great. 2004 Chevrolet Suburban. These guys call me up. I'm in the hospital. Guys, I'm going to be honest with you. You're going to hear it about 10 times. You got to wear gloves. You got to wear gloves. Have to wear gloves. Every class, these guys are my students and stuff. Every class, I go, you got to wear gloves. And I push it real hard. I didn't drink. I didn't smoke. But being an old guy, I probably used a case of brake clean a week. And I did it 35 years ago. Could take down a Doberman Pinscher. Now they're saying it could cause cancer in the laboratory rat. I didn't smoke or anything, but I never used gloves. So I got a liver transplant. And they told me it was from the chemicals. So I pushed it big time, big time. So I was in the hospital. These guys call up, and I do take certain calls even if I'm there. So they call me up and they go, Dave, we got this 2004 Suburban. It's got an 8.1 liter engine in it. And he goes, Dave, he goes, I got a misfire on cylinder number 8. And he goes, I got him on the phone, and he goes, He goes, Dave, I can put a cup of water. We did everything. We did everything. Relative compression, we did everything. Everything like you said. We can put a cup of water on it. It doesn't move. So I said, dude, I want to know the cam and the crank. And I want to see the 4 primary outputs. And four primary circuits. And they're used to using the Fluke 87 and the Tech 2. Dude, got to get a scope. I want to see a picture. I want to see a picture. So they go and they borrow a scope. And they come back and they said, we looked at it, we thought it was the tool, but there's a distortion in the trigger wheel, and it seems like it's happening in the same spot. So I go, you can't go any further, you got to stay there. Can't go further, you got to stay there. So they turn around and they call me back the next day and they go, it had a brand new crank sensor, so we put a crank sensor in it. And this is an 8.1. Anybody see an 8.1? Anybody GM? Where's that located? It's like, you're better off pulling the engine, right? It's about a foot long. It's got 2 O-rings on it, and all of them break, right? So I call him, I go, dude, you can't go any further. I didn't tell you to change the crank sensor. I go, is the pad still there? It's still there. Take it out. Take it out. You got a new one in there, take it out. So get a borescope. I want you to go down there, I want you to take pictures, I want you to rotate it. They call me back the next day and they go, thanks, we appreciate you kept pushing, you wouldn't let us go further than this. Someone took a drill, it broke off the top 2 inches. Someone took a drill and they drilled through 6 inches of that crank sensor and they hit the tone ring. They hit the tone ring. What I don't understand is, why was it 8? If the crank turns 1 revolution for half a cam, we have to turn 2 revolutions to get all 4 strokes. So I go, yeah, okay, you're flashing number 8. What about the mating cylinder? And they'll say, oh, count it up a little. I'm still amazed that it does that. But, and I said to him, well, you can't get your hand in there. How the hell do you get a drill in there? So I figured they'd pull the engine, use one of them Hilti drills for concrete. And the bit had to be like yay long. But G took out the pictures. He trashed my... The pictures were in there, but they basically... The only way to get a sticker in Massachusetts, he's going to have to do what? He's going to put a crankshaft in it. That's the only thing he can do. That's the only thing he can do. I only brought up the 8.1s because they misfire, they don't start. There's just so many problems with those things. And the new updated ones have 1 O-ring. Okay, so you got a mill-light flash under all load conditions. It's a single cylinder misfire detected, which is, to me, is always strange. Check cylinder and companion cylinder. He did power balance, compression. They did everything. With this information, where would you go next? 4 primary circuits, crank cam, injector ignition. Just remember, garbage in, garbage out. And waveform imperfection, they bought it so I couldn't get the waveform. They rotated it. And this is basically, you're looking at, dude, you're the man. I don't care what them nuns say. Right here, this is the drill bit. That's the drill bit. And that's looking down the whole thing. And this actually right here, this is the lip so that the crankshaft sensor doesn't go any further down. It literally sits on that, and he chewed that up too. But right here is there a ring. Here's a thrust washer at the end of the crank. Here's the first ring, and then here's the second ring behind it. And that second ring is more of a flat ring, and it's making sure that when the sensor goes down, we're just picking up right here. So basically, this ring here is mirroring this ring here. But if I go to draw it back, that's how much is missing. So he took out the edge of the... So how does the computer see the falling edge? It sees the first rising, and then it goes beyond and gets the next falling. Again, I still can't believe they got that drill in there. Crank sensors, here's one where the car just basically start, and this is what I want to show you. So the biggest thing with the VR sensors is this. If we have a damaged flywheel, what's that signal going to do? It's going to go up and down. I don't care the fact that it stays and go past the boundary of half a volt. But if that ear gap gets real close, what can it do to the signal? It's going to go up in amplitude. You hit 80 volts, and you're going to reset that computer. You're going to reset the computer. So understand, any high voltage coming out of a signal, you have a chance that quartz crystal inside, you're going to reset it. So this car came in, and again, I want to bring up the point. They put an engine in this thing, and they worked on it. So I came down, and I go, dude, after we do the visual inspection and whatnot, okay, let's do the 4 primaries. This is what we get. Source voltage on the bottom, and we got ground on the, we got reference ground, and we got source voltage. But what's missing? The signal's missing. So I go to measure it, and the crank sensor for this thing, it's like 10 11 thousandths. I had actually written on a piece of paper. And the gap was too wide. So the computer couldn't see it. So do we have any spark in the car? No spark. I turn around, I tell him, take the metal tab off. He's cranking the car over, and what am I doing? I'm changing the air gap by hand. Car starts right out. Starts right out. So I turn around, I said, look, why don't you call the manufacturer and ask him if I can grind down. It's a plastic timing cover. Let me grind it down. We'll come up with the gap we need when the car will start and run. And they said they wanted him literally to take that motor back out. And he's like, no. So you got the point that the customer, the garage, had to go out and buy an actual timing cover because they refused to pull the engine out. That was the only way that they wouldn't send him a timing cover. I don't know if they bought the engine from a supplier somewhere, and the guy, we asked for a timing cover so we could put a crank sensor in, and they refused. They wanted to swap the motor. So the guy went out and he put a new a timing cover in. When he bought the timing cover to try to get it reimbursed, they wouldn't give him the money. It was crazy. Okay, 2001 Pontiac Grand Prix. Quick case study. Customer's complaint. Engine misfires when accelerating. Technician notes. Multiple cylinders misfiring under heavy load. Perform visual inspection. You've got to do a visual inspection. If you see something during your visual inspection, note it, but don't touch it. I want to make sure that's it. I don't want anybody cleaning any. We're going to check the voltage drops. We're going to look at things. But like evap, don't touch anything. I want to make sure that's what's causing the problem. Check the ignition KV output and all the injectors. Verify the customer's complaint. That's the first thing. Check the 4 primary circuits. Check the inputs, outputs. So we go into the module right here. Here's the 24X and the 7X. Here's it at idle. So red is the 24. So that'll be in the front by the harmonic balancer. And the 7X is going to be where? It's in the block, right? Those are nice because they snap off, right? And those are a nice 4-hour job. I sit on a stool and I watch them. I feel bad, but I watch. And I did watch. I sat there. I told Rick I was going to get him a beer, but it was lunchtime. Okay, so again, so let's look at this thing. I've got no problems with the 24. Now I want to look at this. I got an ignition. I got a misfire. We've got it down to the coils. So I don't care about the front. I don't care about the RPM anymore. I don't care about the injectors. I want to look at the ignition on this. So here is it idle. What do we got for a sine wave here? How high does it go? We got it on AC, so we're going up to 2 volts and down to 2 volts. Good signal? Can the PCM see that? Okay? Now, what's distinct about that? There's a double pulse, right? And that usually top dead center. Usually, it can be anything. It can be 30, whatever. But let's say it's top dead center. Now, is the problem at idle? No, it's at 3,000 when you rev it up. Here's 3,000. What's wrong? What happened? Look at the signal. Do you see the double pulse? Now, if the computer's using that top dead center, it's saying top dead center for number 1. So now it knows where the piston is. So now it knows it's going to base ignition timing off this. What happens here? PCM's confused, right? And that's what happens. It's just, it's now lost track of what's going on. Put a new crank sensor in. Peak to peak is what? At 3,000. 16, 14 to 16. What is here? Doesn't even hit 2 volts up and down. So again, it's just garbage in is garbage out. I just can't stress that enough. We got to get a scope. We got to look at it. I know these scan tools are fast or whatever. I'm going to be honest with you. I do not trust any of the scan tools I have. My Tech 2 has identified wrong cylinders. My IDS, I won't say anything about the IDS, but I like it. But I don't trust any of the scan tools. I do not trust any of the scan tools. When I go to a shop, and I'm going to be honest with you, I go to a shop, and the first thing I see is, they'll say, Dave, we got this. And I come in the shop, and they'll go, Dave, we've been working on cylinder number 3. Got a misfire. We changed this, we changed this, we pull the rockers off. We put a straight edge across. I say it's a Ford, I put my IDS on it. I'm on the other side of the bank. I got one scan tool out there that's the most popular one, and they discontinued it. I almost wanted to pay the manufacturer like 10 grand a year just to keep selling it. It's great. It identifies all the wrong cylinders. It's great for me. No, you need that stuff. You need money. Okay. Misfire monitor. Type 8 misfire. Again, we're going to blow through this. I want to get to the case studies. What I'm trying to do is teach you guys some things, use some procedures, and then get right to the case studies. I do want to cover these. We've changed a few things. Right now, we're allowing more failed tests for misfire counts. The whole idea is allowing more failed. It used to be 200 revolutions. Where if it was cat damaging, and the cat was getting up to 1800 degrees, it would start degrading the cat. Cat would start to melt. We would flash the light. At 200 revolutions, it'd be a dead cylinder, maybe 1% to 2% at high speed, high load, and we'd flash the light and whatnot. The problem is a lot of times in the cars when they start cold, we have cold burst. What do we do to a lot of times to get a car going? We double pulse the injector, right? Bosch is famous for double pulsing the injectors. If we double pulse the injectors to try to enrich the mixture, to try to get more surface area just to ignite the fuel, can we have cold burst? We can. The thing is this, basically, they're not going to let, the manufacturer doesn't want the mill light on. I mean, if they could pull the bulb, if they could drill through the bulb, if they could put a 10-hour limit on the bulb and it just burns out, they would do it. But the thing is this, we're trying to do is, with the late model cars, we're allowing more failed tests. We're basically giving the technician a chance to diagnose it if it happens more frequently. So we may find a car that after we get the car up to operating temperature and the light starts flashing, we may let it go 4 or 5 failed tests to get it up to 1800 degrees before we actually do it. And then when we get to 1800 degrees, it could allow it to do a couple more 200 revolution failed tests before it'll set a code. Before it set a code. So a type A, again, everything's 2-trip. Everything's 2-trip. Now I know some guys are going to say, well, I worked on Toyotas, I worked on GMs and whatnot. When they first came out in 96 to 98, type A was one misfire, 1 trip. It was. They allowed it to happen. In 98, they changed it, made everything 2-trip. But they still want to let that light come on. They still want to warn the driver when there's a misfire, damaging occurring on the first trip. If it's damaging occurring, what's going to happen to the light? It's going to flash. What if the light is already on? Still going to flash, right? Still going to flash. Okay. The late model misfire monitors are full positive range, full positive torque. So from idle to the maximum limit it's going to be on. We're going to be checking it. We're not checking on D-cell. When we check it on D-cell, we're actually doing a misfire. The first part of the misfire monitor is we got to check the sensor's ability to produce a signal. We're going to check all the machine accuracies and whatnot when we do a cam clearing. That's the first thing. The first few D-cells, the computer's going to look at the crank. It's got a stored data inside of what a perfect crank to trigger wheel is, sensor to trigger wheel, and it's going to compare that. It's going to compare that. Okay, so with the late model vehicles, the misfire monitors have allowed more 200 revolutions and more 1,000 revolution fail counters. Again, the idea is to give the technician a chance to diagnose this thing if it happens more frequently. Again, using similar windows. Now, from idle, about 2,000, from idle speed to the red line, that's what the cars are going to do. 4, 6, and 8 cylinders. If it's got a V10 or a V12, we're going to go back up to where it originally was. We're going to go up to a 30%, 35% load, and we're going to go up to 3,000 RPMs, and that's it. Because if we have more cylinders and we have more revolutions, what's the chance that the PCM can actually detect the cylinder that's misfiring? Slim to none, right? Slim to none. So basically, all the cars are on the bottom, and the V10s and the V12s are on the top. Misfire monitors, temperature, calculated temperature model stored within the PCM. Again, RPM and load. Cadillac, want to get up to 1,800 degrees. When it gets to 1,800 degrees Fahrenheit, it will cause immediate or permanent damage. During a cold burst, the calculated temperature of the cat, as well as the failed counters, have to be reached together. In other words, when the cat's ice cold and we have a cold burst misfire, what's going to happen to the emissions? It's going to be the worst polluting of the car. So we're going to monitor that on the first 1,000 revolutions. But as far as setting a hard fault DTC, we're going to make sure that cat's up to temperature, and we're going to make sure that the failed counters for RPM and load, they break the counter and the temperature of the cat's up before it'll start actually counting the misfires. What could prevent or suspend the misfire monitor from running? Low fuel level, low ambient temperature, high altitude, charging system voltage. Over 16 or below 11, it's going to shut it right down. PTO activation, anything else? How about cam clearing? We clear the cam, we got to do what? We got to relearn it, right? Here's a typical, this is a P300 of a GM. And none of those DTCs can be set. And then basically here's the criteria before it actually sets a PO300. Scan tools. This is a big precaution I have. The data you're viewing, I hear this all the time. I don't care if you put 4 PIDs on there and the refresh rate is fast as could be. If you pick 4 PIDs, and let's say the first 2 are high priority, and the next 2 you pick are low priority, just because there's 4 on there, doesn't it got to go from high? Doesn't all the high priority go on the bus first? And the low priority what? Now, if we got like a vehicle speed, if we could take an axle, like say a Ford, we can come off the rear axle, right? And that speed sensor can go to the ABS unit. And then from the ABS unit, it's going to go to where? The PCM, right? And then it's going to have to, so it's got to get processed. Now you put on your scan tool, what's it going to do? It's processed again. So it's going to be processed at least twice. The accuracy of the scan tool data has to do with the accuracy of the coding. Just real quickly with this. If the OEMs sell coding to the manufacturers, the aftermarket scan tool manufacturers, it depends if they check it or not and how good they check it. There's basically lookup charts. And everything that comes out of the modules is hexadecimal. And we got to convert that to language that we can read and understand, right? So we're going to do it. Now, if they take that hexadecimal, say for a TPS, and they don't look it up right, and it comes out as a MAP sensor, MAP sensor, and identifies the wrong sensor, what about the reading? Every hexadecimal signal, it's got a conversion so it knows what the sensor is, right? It's using the hexadecimal, and it's doing a multiplier, which is, we're going to call that a test. So if I identify it for a MAP sensor, and it should have been a TPS, what happens to the voltage reading? Isn't that wrong too? It's wrong. If you see, scan tools are great. If you see something that you don't like, I just want you to verify it. That's all I want you to do. Don't trust it, just verify it. Terminology can change from scan tool to scan tool. Remember that some guys like to follow the charts. I'm not a believer in charts. That's just me. Remember, mode 6 test results. Pre-can have substituted values. The biggest thing with this, I still want to tell you, because a lot of guys work on the older stuff. If you don't look at the substituted values, could you think that a test has been run? And some of these scan tools, if you do a cam clearing, it comes up and it says what on mode 6 test results? It's got substituted data and it says failed test. Guy's got an evap code. He goes into mode 6. He sees all these failed tests. I show up, he's got $1,400 in parts in the car. And I look at it and I go, he goes, Dave, look at it, it's all failed tests. He goes, see, look at all the readings. I go, do me a favor. It's not PC based. Let's write a few of them down. Clear the battery. And let's look at the numbers. And they stayed the same. They stayed the same. So basically, since the last time that test ran, or since the last time there was a code, has it ran again? If the criteria isn't right, and it's a temperature, could it run all winter with not running the test? But understand, just verify what you're looking at. I don't like it. I just don't like when it sees failed tests and stuff like that. We do have a lot more information. We got injectors shorted, injector open circuit. It's a great thing to do. They show you the injectors are disabled now. But if you see that, like we got a misfire history here, cylinder 1, 3,132. It doesn't say any okays or shorts or whatnot, or opens. It doesn't say it disabled any of the injectors during it. But it's history. Now, as far as current, is anything happening right now? But the thing is this, I would have liked to have known in history, did it shut the injector down? Was there an open? Was there a short? There's more information now, use it. But again, I just want you to verify everything you read. And again, the aftermarket, same thing. Whatever you have on it, you're going to have on your aftermarket too. Open shorts. Here's that same car. We got it to act up, and we got a what? Ignition control for cylinder 1, right? When I got it to act up, where'd it go to? A fault. So the aftermarkets work just as good. The factory, I like the fact that, you know, freeze frame, Ford takes it a little further. They've been doing this since 1999. But they'll give you the throttle position, engine soak time, engine running time at time of misfire. They'll tell you intake, they give you a lot more information than just a regular typical freeze frame. How many times have you had a vehicle that has adequate spark, fuel, and compression, and the engine runs rough or will not start? Isn't that a common thing, seriously? You show up, or the car gets brought to you. They got spark, right? Because the guy just got nailed. He hits the Schrader valve, it clears the fender. All right? And then he puts the compression, puff, 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 puff. So now he says, I got everything. But realistically, if he throws a compression tester in there, if the valve time is off, can we still have fairly good compression? If it's advanced, could it be raised? Right. Now, if we're using a Nord light, does the Nord light really tell you anything? Does it even load the circuit? It doesn't load the circuit. And then the spark, I have everybody get the adjustable spark testers, not the Dexter ones. I want you to get on eBay, and you buy them for $4 or $5. The one with the plastic knob on. You'll see some of these videos. I'm sitting there. If I got no spark, I'm not going to use the fixed ones, and I'm not going to use those neon ones. Throw those neons away. Those things are only good for pulling the cassettes out, extending the wires, right? And taking your test light and killing cylinders. That's all they're for. I go in a shop about a year before I went in the hospital, and the guy goes, I got great spark, and all I can do is smell fuel. And he's got it coming out of the coil, it's flashing, he's got to go in the cylinders flashing. And I go, you know, I'm a moron, and I'm an old guy, and when I worked in cars, American cars, when I was a kid, when I grabbed that coil wire, what's the first thing that happened? I smashed my elbow against what? The spring on the hood, which is probably stronger than most strut springs are in a car right now. Nailed it. Oh my God. Yo, said words I never knew I knew. And I look around and I go, oh, I'm going to break the little pole. So I grab the thing and I'm holding it. And he goes, see, it's got spark. It's still flashing. And I can feel it inside my hand. It's going like this. And I go, come around. He goes, what's the matter? I go, let the boss crank it. I go, see what I'm doing? I'm holding your neon. I grab the whole copper part. And it's still flashing even though it's going through my veins. I think it was alcohol. I think I made a good conduct. But again, you know, we always taught combustion triangle. For it to occur, we need compression, we need ignition, we need fuel. And I get it's sufficient amount, adequate and sufficient amount. That's the way we were told. High school, Franklin Institute. That's what I was told. I want everybody to think of it as a square. Because the biggest thing I think is the timing. Everything's got to work in correlation with each other. The piston and the crank, the injector. The injector's got to fire at the right time. The ignition, everything has to fire at the right time. So we want sufficient compression. We want sufficient fuel supply and control. We want sufficient spark. And we want correct time. Everything has to be related. That's the only way we can make the combustion process work. Let me give you a quick example. This guy asked me to come in and look at this car. He was one of my students. I just couldn't get there. And this car got it got a distributor, it got an EGR, got a distributor, it got wires, it got plugs, it got everything. Here's a normal waveform that's good. Let me just tell you it's good. This top dead center is all 4 strokes. This 360, this 720. Right there, the exhaust valve opens. Right there, right before 360, the intake valve opens. After 360, what happens? It's overlapped, so it closes. The exhaust, right? And to build up compression, we got to close the intake. Once we close the intake, we build up compression. So basically, looking at that right there, we know when the intake valve opens, we know when the exhaust valve closes, we know That's what we need to look at. Just think about it. It should be in your book. Okay. Car comes in. He says, Dave, I got a misfire, cylinder number 1. Now, I go do relative compression. I'm going to do that first. I'm always going to do it. I don't care about the scan tool. And so I don't even have time. I said, look, I'll give you 10 minutes. That's all I can give you. And I'll pull in real quick. So I go, look, I want to do, he's got a distributor, so I can't get a crank sensor. So I said, look, the best thing to do is I'm going to do a pressure transducer in the hole. And then I'm going to check my ignition and my injector time. First of all, I'm going to find out if they're actually working, if there's supply voltage there, if the computer's pulling it down and releasing it. Is it doing it at the right time? So let's look at this. Right here, here's 0 degrees. So that's top dead center, right? And here's the blue. That's the ignition. Ignition control. We know that's going to happen before top dead center, right? So is that where it's supposed to be? Now let me get rid of the crankshaft degree. Okay? Now, the yellow is what? Injector control. Now, what I did with this laptop, Bernie keeps trying to fix it. Every time I send it, I go, don't touch it, I'll be pissed. For teaching aid, this is an 8-channel scope. I got somehow the yellow for the injector is at 0. For some reason, that's really 14 volts. Okay? But what it is for some reason one day I came out, I dropped it, and it pulled down. That injector lays perfect on that waveform. So I sent it back to get a battery fix in. He goes, dude, that number 1, I'm going to fix that. Don't touch it. Don't touch it. Because normally the injector pattern, if it comes out at 14 volts, gets pulled down to ground. Where is that pattern? It's much higher up. Okay, now let's look at this. I'm going to get rid of the crank. What do we know about the blue ignition timing? It's happening before 0 and 720. Is that good? I can actually, with the crank degree wheel here, crank degrees, I can put a cursor in there and I can tell if the scan tool is accurate with that. Okay, now, what's the yellow one? The injector. When's it firing? We got compression and we got decompression, right? We don't got a power stroke. What's the next thing happening? The exhaust is going to open before bottom dead center. And then when the piston goes back up at 360, we have overlap. When is that? He says to me, I didn't put an injector in because the top of the piston's got fuel in it. I know it's getting gas. When did the injector spray? Just before the exhaust valve opened. Okay, now, there's 2 problems with this thing. It's either 1 or 2 problems. What can be wrong with this? There can only be 2 things. Either the computer's turning it on, grounding it at the wrong time, right? Or what? The harness is switched. How many misfires does he have? He's got 2. He's got 2 dead holes. Got plenty of gas on top of the piston. He got 2 dead holes. So there's a big thing. I mean, we got a lot of time in it. Just dropping that pressure transducer, checking the ignition, and checking the injector saves a ton of time. Saves a ton of time. Now, here it is again, and then this is it afterwards. Now, this happened to be a really early car. It was actually a truck. It was a coffee truck, and I ran down to do it and whatnot. So they're actually spraying, and I do see the real early ancient cars. They'll actually spray during the intake. It's very inefficient. I mean, we should be spraying it when the valve is closed, when the intake valve is closed, before 360 like we see, but this is an old car. I don't even think I got a scan tool for it. Okay, Ford Explorer, customers claim it ran rough, now will not even idle. Mill lights flashing. Diagnosed revealed intake damage. Check the compression, ignition, kV output from several cylinders. Check the cam and the crank correlation. I got this shop to buy a scope. Well, actually, got them to take their motors and look at the scope. Dude, you got a $5,000, $8,000 machine. Got to use the scope. They got a new technician. I showed him how to use the scope. He comes back, he says, Dave, the cam and the crank are lined right up. I'm just going to ask you, that's the whole point of this. I'm going to blow right through it. Can the cam and the crank be lined up perfectly, but the valve timing be off? If I got a 4-liter Explorer, and I got a cam sensor, and it's on the driver's head, what about the passenger side? If I have a Saturn, and I got 4 cams, and the cam sensor's on the exhaust in the front, can I be right on? Can the back be off? So this is what I did. So now look at this, what this car got. Damage revealed the intake. The car wouldn't idle, wouldn't even run. He could just keep it idling. Had a huge hole in the intake. So he turned around and goes, well, that's why it won't idle. So he put an intake in it. Now, before he did that, he decided to check, it's a 4-liter, so it's an early one, like 2000. So he wanted to check the cylinders, and he figured he'd check a couple cylinders. Which cylinders did he do? The driver's side, right? Because the passenger side, the intake covers it, so there ain't a problem with that, right? So we're going to check these, and they're right on. Where's the cam sensor? Right on. So he put in, he placed the intake manifold, spark plugs, 2 ignition coils. Then he had no power. And he put 2 converters in it, and he changed all the O2s, and it was plug solid. So I came in, he goes, Dave, but we did what you said. It's dead nuts right on. I go, yeah, but we got to think this a little bit through. What happens if we check it on the S-ball? The manifold was on top, it was all melted, blah, blah, blah. So we checked this side, and it was good. I got, what's the driver's side? It's in red. What's the yellow side? The other side. So when we injected the fuel and we ignited it, it basically went into the cat what? Where was the combustion taking place? In the cat. And just understand, that's what happened. Another one, Saturn, ton of parts. Matter of fact, me and you played it with it. Ton of parts. And it was on I bought another, I bought one of Bernie's gas analyzers. So a lot of times what we'll do is, me and Rick and Mark will get together and we'll fix a car. And all we got to say is, we're going to fix the car with a scope. No scan tools, nothing. We're going to fix the car with a scan tool. We're going to fix the car with a gas analyzer. That's it. And that's what we do. We play. So this car came in. It needed a ton of things. And he, again, checked the whole thing. Cam and cranks right on. And it is right on. And here's the cranking waveform. And this, again, the exhaust on a cranking waveform. I'm not going to get in detail right now. But right here, because, geez, screwed me out of 15 minutes. I want that back. The exhaust opens right here, 30 degrees before bottom dead center. You can see a little drop right there. The intake valve's opening. And we know the intake valve is actually going to close when this goes up. So basically on a car, if we have a car with the RPMs varying, we get a no start. If we do a crank and compression, we're going to know, basically, we can figure out the duration right here and know if the timing's close enough to start the car. We get cars like Nissan, we're off 1 tooth. Does it start? No. And if it's a late model, what can we do? Just yank out the crank sensor or the cam. It'll start right up. Okay, look at this. This is, the car's got misfires in the back. Change the cassettes, change the coils, change everything. Injectors and everything. It's supposed to open at 30 degrees, right? What's this? It jumped. It jumped. And I always want to do the root cause. The root cause is what I want you to find is the root cause. Car comes in, no power, the cat's clogged. We throw a cat in. Is the cat the root cause? Now we throw a $2,000 cat in. Is it coming back in 6 months? Is the plug too cold? Is the injector dripping? Is the valve timing off? We got to think of this. The root cause. I don't care about the effect. We'll fix the effect. In most cases, what I did this class is basically I'm looking for broken springs. I'm looking for stuff that takes a long time to figure out. What happens if all the injectors are at 90% and one's at 70%? Is that a misfire? If we have 102 doing both banks, can that extra oxygen be taken out? Would the fuel terms be off that much? No, and could the new cat correct it? It can. So what I'm saying is that 70%, we have a density issue, right? Do we have a misfire? Yes. Those are the hardest ones to find. But again, the biggest thing, we got to figure out where the cam's located. If the cam's on one side of the motor, we got to look at the other. And that is why I like to use the pressure transducers. We just pull a plug out. Simple plug tells us a lot. Diagnostic, these are my golden rules. Do not be misled by other people or recent repair history. When I go in a shop, I don't want to know what you did. And it's not being rude, they know that. If you did something, I'll find it. But I want to start from scratch. When I started out, I had all these guys come up to me, the boss would come up to me, real good tech. It's not a power issue. But I don't have 5 volts coming out of the PCM. So now I'm going off looking at something else. And I knew to put a headlight, not a test light, not a multimeter. I knew to put a headlight on all powers and grounds. He talked me out of it. They come to your shop and they're going to tell you, I go in the shop, Dave, we know it's a PCM. Well, why am I here? It's a $1,400 guess. People think I'm anal because I need to find out what circuit's acting up. Because when I change a $1,400 part, I want a good feeling right here, right? I don't want a feeling somewhere else, do I? No, so I want to make sure. If you know what's wrong with the car, why am I there? Now, I also say, this is for Identifix. This is for Identifix. If they come on, I have this all the time. We looked up Identifix, we got a problem. They changed 32 solenoids and 2 evap canisters. We changed them, I still got a problem. Wait a minute. They made 1.4 million of those cars. 32 of them broke down? Are you serious with evap problems? So they'll actually change everything. I want to do is I want to make, you got somewhere for a reason. You got there during your testing. You're following your testing. I don't care if the car's got electrical problems. Let's use electrical. It could have 20 problems. Lights don't work, but I'm going to find one thing. Left headlight don't work. I'm going to go after that headlight. Most likely, it may, if it's a ground issue or a power issue, could it take care of the rest? I'm not going to look at a schematic with 200 wires on it. I'm going to go after a symptom. I'm going to stay with the symptom. I'm going to do my testing, and I'm going to let my test find out where the problem is. It's going to lead me down the road. I don't like jumping around. That's what the diagnostic sheet's about. Always start from the beginning. Defective components, inadequate repairs. That's what we're looking for. You're going to note it, but you're not going to touch it. Look at the symptom. Concentrate on the symptom. Follow your diagnostic process. The test results will lead you to the root cause. Trust your diagnosis. This is the biggest thing I have. The biggest problem I have with everybody. I push, I push, I push. When you change a part, test it. You use the test method, whether you scope or whatever, to find the crank sense is no good. You change it, you test it. Too many people put the part in, doesn't fix it, now they're over here. They're over here, they're over here. When you put, don't second guess yourself. You guys know what you're doing, the test results got you there, retest the part you put in. There's so many brand new cars out there, airbags, everything, coils, sensors, and the parts are defective right out of the box. Factory parts. Last rule and most important, know your equipment before you start. Functionality and limitations. You're looking up a code, and you got a Kia, 2009 Kia, and your software goes up to 2002. You know, it's like, you give it a shot. You can still use a vacuum gauge. You're working on an old car, you got a plane about this high. You don't got this, you don't got tubes and everything. You got a manifold that's about an inch high. We can use a vacuum gauge, okay? Because we don't have this huge intake, but you go get it, the glass is cracked, and where's the needle? Down the bottom, so you're smashing it on, and you're duct taping the glass, and how accurate is that? I say they shouldn't bounce. That sucker's broken, it's sitting right there. It sits right there, it sits right there. Just use the tools, understand what your limitations are, because that's where you're going to use the test result. Oh yeah, because you guys got to fill it in. Concentrate on the symptom. Again, if we got multiple symptoms, pick one. Stay with it. Stay with it. Stay with it. Don't jump around. Yeah, you guys got to fill in the book. And then you got homework. You got a test. I grade you after lunch. Okay, terminal tension issues, big things. The biggest thing with these is a lot of harnesses aren't getting back where they belong. They're not getting back. And we got more problems with melting and pulling and whatnot. Anytime there's a right-hand corner, you're going to have a break in the wire. You're going to have a break in the wire. Constant vibration. The biggest thing with this is this. Open circuit testing, we found the map is no good. But we go to test the power, the reference, and the signal. I don't want any open circuit testing. Don't be putting the probes in there. Just touch the probes. You guys all know to do that. But I go in, they got a PO 101. It's a bad map. You tested it, it was fine. But now you're still got a PO 101 because the terminals got expanded during your testing. See, I just don't want to, that's the biggest thing. So, no open circuit testing. Try to back probe everything. Most of the time, you know, I've got Massachusetts, you guys from New York. Our weather pack connectors are meant to keep the oil and water in. Not out. It's meant to keep it in. and they're like concrete. So we drill the weather pack, and then we shove one of these things in. I'm not a big fan of of piercing the wire. But if you pierce the wire, we're only, again, piercing the insulation. And you got to cover it. You got to put the liquid electrical tape. I don't care if you use nail polish. The only problem I have nail polish, if I open the drawer and you're using nail polish, and you got like 20 different colors, I'm thinking there's high heels in the bottom. You're starting to freak me out. You're starting to freak me out a little, okay? And so you got to use the liquid electric tape. You get this stuff, you open it, you flip it upside down and store it. You get these, you open that can, a week later you go to use it, it's solid. What does your tire cement look like? Flip them upside down. Flip them upside down. Otherwise you'll be buying these cans every week. Load test the circuit. Usable, suitable load tool. I use a headlight. Then backup lights, I load test everything. Do not load test the circuit going back into a module. Disconnect the module, disconnect the component. Load test. Put the headlight in the circuit. Most of those rear lights that I use that fit on the bumper draw 4 amps. Then I'm going to start grabbing the harness, doing this. What am I looking for? I'm looking for the light to flicker. Most of the times, I have a lot of times where they come up and I'll go up to a job and they'll say, they change all this stuff and the PCMs change and whatnot. They got the same problem. And I go look up the powers and grounds and they got the test light and it goes light, 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 light. And I go, dude, we got to start from the beginning. We got to load test every module with a headlight. And I go bright, bright, dull, off. If I take 2 circuits away from a module and I got 4 powers going in a module, am I powering up different sections of that module? There's a good chance that maybe some drivers aren't working. There's a lot of things aren't working. You got to load test the circuits. If you pierce it, again, you got to seal it. Garbage in, garbage out. Never replace an electronic control unit without properly testing what circuits. Power, ground, and what? Communication. But you got to load test them. Okay, diagnostic process. It's always good to get the vehicle's previous repair history, but don't let the information lead you to the diagnostic process. Do not let it lead you. Take the information a grain of salt. Just because it left the training shop and it doesn't start, is it a training issue? No. If the cam cranks off, is the flywheel off? Because the timing belt jumped. Always perform a visual inspection, the undercarriage as well as the underhood. Perform the basic test. I want to do the charging system. I want to record all the information and the module information. Use and follow the Misfire sheets. They're right in there. Visual inspection, big thing. Should include checking for previous repairs, component wear and damage, including collision damage, harnesses incorrectly routed and not secured properly, and I'll be on add-on aftermarket features. You got to check them. Everybody likes to tag into an injector or a coil. It drives me nuts. Fluid levels and condition. This is a big thing. Fluid gauge can't be on E. If it's on E, just don't bother driving it. It's got to be at least a half a tank of gas. The level is adequate to prevent lean air fuel mixtures. I'm going to crank down here a little bit more. What I'm concerned about, if the oil's in bad condition, you got to get consent from the customer. What's good about me, you guys own the shop. I'm going to take it for a ride. I'm going to come back and say, John, thing's got a rod wrap. Well, I didn't get the nose off the ground, but it's got a rod wrap. So you got, if we pull it out of this mud, you got to get the customer to say, look, you got to sign off because we got to drive this erratically. But the biggest thing I'm looking at this, coolant. I get a lot of problems. I get a lot of intermittent misfires. That seems like it's the biggest thing lately. Small amounts of oil or coolant can be masked. We can have a head gasket that leaks when it's cold. A small amount on a cold day. If that cat is 1,800 degrees, 1,400 degrees, will that come out as steam? If that level, if the customer's adding it and you're just seeing the level full, are you an indication that it might be using coolant? Understand, we can take a little bit of oil, we can take a little bit of coolant, and we can burn it. And unless you get it actually leaking, I don't get a smell. We're going to cover that on one of the jobs. Charging system. Corroded battery cable ends, positive or negative. Loose terminal to cable contacts. What type of issues can the excessive voltage drop create while driving? If you take power or ground or put excessive voltage into the PCM, what's going to happen to the module? It's going to reset. I went and I worked at a dealership and they had a car, a van, and I went in there and they said, Dave, we can't go, it's misfire, it's bucking, whatever. If they're resetting, can that feel like a misfire? It can, but it's not a misfire. It's a PCM doing what? Resetting. So the guy's talking to me, the service manager's right here, a good friend of mine, and the tech's going like this, and I'm an old guy. Do I have to look at him to hear him? So I'm not ignoring him. I'm listening to the guy, kids tell me. So I'm going around wiggling. I'm an old guy. Touchy-feely, you know, I'm just one of those guys. So I'm grabbing things, and he looks at the service manager, he goes, he's not listening. He goes, Dave hears every word you say. I go, you want me to repeat it? I don't need to look at you. So I grab the negative cable, I go to move it. I grab the positive cable, car shuts off. The truck shuts off. Car had no extended cranking, no delayed cranking, nothing. But it hit a bump, what did it do? It reset every time. And they load the back with fenders and quarters and everything. PCM resetting. What about a low kV voltage? How about fuel pump? If I take the voltage away from the fuel pump, what's it going to do? What's going to happen? I don't care about pressure. Pressure says 35 to 64. Is 65 bad? Is 33 bad? Who the hell knows? So I want fuel volume. That's what I concern myself with, fuel volume. This is what I normally see. It's funny, I got pictures of snow cones. I opened the hood, they got all this new stuff. And they got snow cones. And I'm like looking at the hood, I'm surprised the hood ain't shorted. And I just want to spray one grape and the other one like apple or something, you know what I mean? But it's got a new alternator. Or I'll open the hood, and I think they think it works on fairy dust, but the tensioner is at an angle, and the rubber belt has gone through what? Right through the plastic covers, and I'm like, okay, you don't think that has a problem? You know, how can you, it's like, most of the drivability that I do right now, it's electrical. It's electrical. Can we fire the plugs if we don't have the KV? If we have low voltage on the primary, what happens to the secondary? Everything suffers. Everything suffers. This is that, the dealership truck. I just touched it and shut right up. But I turn around and he goes, no, Dave, it starts right up. Cranks over fine. Wow, hit a bump and it's, whoa. What is this right here? This is a reset. We're sequential, then we shut them off, and then we line them all up again until we learn the cam and crank position, and then we'll fire them sequential. That's asynchronous, I believe it's called. I always get the word wrong. Anything bigger than delicatessen, I usually get wrong anyhow. But asynchronous, then it goes, once it learns cam and crank, it'll go back to it. But that's a PCM reset. I'm a big AC ripple. AC ripple, understand, if the alternator is putting out a lot of noise, it can affect circuits. It can affect the sensor circuit if there's a sensor nearby. Now, a lot of guys won't bother doing this. I just make sure that these humps are supposed to look like a picket fence, M's or whatever. I'm looking for one of these that basically even across. If one drops down, then I'm going to have a problem. Most of us use automatic testers. I even got a micro bat from Snappy. You'll read in a book that it says up to 500 millivolts. I prefer 150. My limit is 3. But just understand, 300 millivolts on a new car could be a problem. So I like 150. If I see 200, I got a problem. I got a problem. And the biggest thing with voltage drop, had a car come in. Lady says, all she was caring about was all the lights were on the dash. I had misfires everywhere, couldn't care less. All the lights were on the dash. Turn the headlights to low. The guy checks the charging system. He got 14.5 volts coming out of the alternator. At the alternator. I got 12.5 volts at the battery. Where's the voltage drop? Between the two, right? The thing, I had low KV, I was misfiring like crazy. No, at night, oh, don't worry about that, I just step on the gas a little harder. But the headlights don't get bright. I can't see where I'm going. And all the lights light in the dash. And it bothers me when I'm trying to look over the dash at night. Understand, that's what I'm looking for. That's what I'm looking for. Crank and amperage test, also referred as a relative compression test. Crank and amperage test, pre-testing conditions. Make sure the vehicle battery test okay, it's fully charged. It has to be. Otherwise, you're going to get these crazy waveforms. You'll see one I haven't changed. If the battery's low and I go in the shop, I'm going to turn around and say, if I'm looking for a misfire, I'm going to do relative compression. I'm going to have them throw a new battery in there. I'm not going to do a relative compression with a battery charger on it. What's going to happen to my oscilloscope? Can it get twice as much noise on it? If the starter's old and the brushes are all worn, can I get a lot of noise on it? If you're going to use the old battery and you charge it and you're going to be cranking it, because I want to fill the whole screen, throw a battery jumper box on. Just don't put 110 on. Ensure there are no large voltage drop in the starter circuit. Make sure the starter's operating properly. If the thing is spinning like crazy, grinding, don't bother doing it. You're not going to get a patent you can use. Disable the fuel injectors. Make sure the batteries are good in the amp probe. This is my problem. I'm a dummy. It costs me 10 batteries a month. Because the little button that says shut off, I'm just not smart enough to shut it off. So Snappy says, oh, I'll sell you one that automatically shuts off. Yeah, for $400, I'd just rather keep buying batteries. But it's funny, I use 2 amp probes. So how many batteries do I put in every week? 2, so I got to buy a 10-pack. Buy the ones that shut off. My students know John Thornton over there has a lot of patience when it comes to me. A lot of patience. John's been teaching me for a lot of number of years. I give him credit for everything he does. These guys hear about him all the time in every class I have. John, about 8 years ago, I'm doing all my drivability. We're up at Linda's talking. He goes, Dave, you got to do relative compression tests. I go, John, I'm doing all this stuff. I go, I don't have time for that. Dave, you got to do relative compression tests. Now I'm telling you guys, you got to do relative compression tests. These are John's numbers. Normally aspirated engines, we're looking peak to valley, we'll cover that, 30 to 35. These are great numbers. These are great numbers. They're also written in, say, John Thornton's numbers on your diagnostic sheets. I show you a good one, I show you a bad one. High performance engines, 70 to 75 amps, peak to valley. Diesel engines, 110 to 115 amps, peak to valley. Crank and amperage test. At times, the crank and amperage test waveform will not appear clear and precise. Starter condition, battery charges, we just talked about that. But you'll still be able to detect a low or non-contributing cylinder. High performance with turbo, we're looking at multi-valve, multi-cams. But we're looking at, when we crank the motor over, we're looking at compression ratios at idle. I mean, crank it, 200, 2 1/4. We're not looking at the 140, 150. Hello. The alien's coming out. Okay, but even though it's noisy, you do it. Now, another thing. John taught me that, and it works great. We have 2 cams in the car, if we have 2 cams. The intake cam determines compression. So when we're doing a relative compression test, and we got dual cams, and we're on a 4-cylinder or a V6, what are we looking at? We're looking at the intake cam. The exhaust cam determines combustion. And I need you to break it up like that. So I do a I got a 4-cylinder engine. If the intake's right on, can my relative compression be good? Can the exhaust be off 2 teeth? Yes. It'll be off 2 teeth. Just understand, you know, again, I go to school, I learn this stuff, and every time I have a class, I love to share what I know. John shares everything with me, I share everything with you guys. I just constantly want to share everything. And I tell you, he's the guy to listen to. I can't give him enough credit. This will give you the starting for your diagnostic process. Now, here's a 2008 GMC 6-liter. Here's a crank and amperage test. Is there anything wrong with that? Are the peaks they're right across, they're really similar, right? In the valleys. They're fine. I get 59, I got 40 pounds. 30 to 35. Am I right on? I'm right on. I can actually clean that up. I can hit the smooth button, clean that up a little bit, but that's fine. There's nothing wrong with that waveform. That's an example of a good waveform. Now let's look at this one. I get the whole waveform there, then I'm going to break it up here. What do you see? How many cylinders is it? How many cylinders? 1, 2, oh God, I'm drinking. 3, 4, 5, and what's this? Now, what I do is when I show up to a shop, don't bother putting the scan tool on. I want to do relative compression. What happens? What's the event that happens at top dead center? What event? Ignition or fuel? Ignition. So I'm going to get any coil. And when I sync the coil, all I got to know is what? Put the firing order, and I'm done. And then I'm going to go look in, then put the scan tool in. Let's see if the scan tool is right. You'd be surprised. If now you know that they act up or they're not always correct, they don't give you the precise data, you're going to start looking. Look at this one right here. Relative PL301. We have an issue. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, I can clean that up. But we don't care about like this first one here. This is the after event. Why is this higher right here? The crankshaft did what here? Spun real fast, didn't need much what? Amperage. That'll never be flat. You know, you can hand draw them. I do that sometimes in class. Put them on the board. That'll never be. Do we still need amperage to turn the crank? We still need amperage. But now, that spun it with no effort. And then the next compression is going to do what? Okay, simple crank and amperage test. What do you notice about this? How would you locate a cylinder? Again, just firing order. Again, we draw it like this. I only put this up here for this. 1, 2, 3, 4, 5, 6. That's either a good cylinder, a good engine, or it's what? Now, that could be dual overhead cam, like you just said. Now, if that's a dual overhead cam, and I'm misfiring, how can I quickly identify it? I can pull out a plug, right? Drop a pressure transducer and I'll know real quick what's going on. And if I'm on one bank, which plug am I putting out? The easiest one to get to. The easiest one to get to. Okay, 2004 Toyota Camry, V6, 100,000 miles. Complaint, runs rough, milliamp on, DT stored for both banks. Can one bank act up on the other? Can one bank affect the other? Okay, during the diagnosis, the technician checked the injector control, spark KV, fuel pressure. Replace the plugs, the ignition cables, reseal the intake manifold before the carburetor treatment. They pull the manifold off twice. And then they put injectors in. I come in there, and these are dealer guys. I come in there, and here's the waveform. Now, I want to zoom in a little bit more. What do you notice about that? Now I keep cleaning it up. What's it doing? So it goes high, low, high, low, high, low, high, low. I'm done. I'm done. I can't. One side took 40 amps to push up. The other side took 20. One bank fires. High, low, high, low, high, low. I sync it off this. Now, I sync it off this. And so relative compression told me what it was. Now I sync it off this. And this is that's a full one. Over here it's a short one. Over here is a full one. Over here is a short one. How many coils in the car? It's a V6. How many coils? 3 coils. So I turn around, the guys are, that doesn't make any sense. Okay, do me a favor. I got my stool out. I got one guy take the plug out in the back, and he worked at it for about 40 minutes. I said, dude, you should put wing nuts on the intake. You're going to pop that right off. He had it off twice. And the other one did the front. So he cranked it over, and the front, the timing is right on. But, so the waveform is perfect, and the other one's off like 40 degrees. So I said, dude, the time is off. But there can only be 2 problems. What are the 2 problems that it could be? 100,000 miles, this cam is off. Cam here and a cam here. This cam, 40 amps, 20 amps. 40, 20, 40, 20, 40, 20. For that to be off, there's only 2 problems it could be. What are they? Either the what's off, the belt, which is most likely, or what else? No. The gear to the shaft. Just don't forget the gear to the shaft. I go to the shop, Dave, we put the timing belt on 3 times. It's lined up perfectly. I told the pressure, dude, the time is up. The time is up. No, put the chain on, put the gear. They'll do it 3 or 4 times. Dude, it's off. It's off. And what's defined is the pin shear. I'll have examples on that. 17 minutes after the class ends. Okay. Only 2 mechanical issues. Crankshaft to camshaft out of correlation, or camshaft gear. Don't forget the camshaft gear. Go to a dealership. They had a 2-year-old Dodge, interference motor, bent all the valves. They strip the head, they bring it down. They go to the machine shop, they bring it back. They said, Dave, we put it all together, leaks everywhere. So I turn around and they go, will you take a look at it? I said, be glad to. And I'm going to go from the basics. I'm going to keep everything simple. So I have them take the belt off. I take the pistons, I drop it down. Get them all in the middle. And then I look at the cams, and I put them where I believe they should be. And I make sure there's play. Then I bring the piston up, I take my TDC indicator, I put it on without the belt, and there's no leakage. Then I look at the gears, and I'm going, geez, if you take this one off and you put it over here, do you know how the marks line up? But if you reverse them and you try to line them up, what happens? You're off. So I started saying, why did you take the gears off? I'm surprised. But they changed the seal, so it made sense. But when they brought it back, they didn't mark the gear to the thing. So when they put it back on, what happens? John taught us about, he did a Hyundai where they put the cams on wrong. And we're driving up here, and Bob's telling us, oh, I had this Honda, and it came from another shop, and it went to the machine, and it bent all the valves, and he found out they put the cams wrong. I go, dude, we heard that like a week ago, Vision. You should have come to Kansas City with us. Could have saved yourself 5 hours. Call John. Okay, here's a different Toyota. Is there a correlation issue here? Look at it. Car runs like poop. We say that in Massachusetts. Look at that. What do you see? How about now? Oh, gee, stolen. Come on, dude. I know you want to cut my time down. They're pin sheared, and it moved about 30 degrees. Moved about 30 degrees. So I just want to bring up cam and crank. Diagnostic tools. Big fan of this. Gas analyzer. Go with Lamba. No drilling out the pipes. I still see people drilling out pipes. It freaks me out. When you use Lamba software on a gas analyzer, if that's it's available to you or you have one or whatnot, if you use the Lamba software, it's not affected by the cat. So whatever's coming out of the motor is going to reach at the tailpipe, as long as you don't have any air leaks along the way. Cylinder leakage test is basic. Biggest thing on this side over here, stable in 22. Got to get stable in 22. On the air holes, 5/4 is the biggest thing. Springs and rings, springs and rings, springs and rings. That's the opposite with the 5/4s. There's the adjustable spark tester. I want you to adjust it. The spark tester, you got a fixed one. 25 kV, the spark doesn't jump. You put a 15 kV, spark doesn't jump. What does that tell you? Don't tell you squat. Now, I take it and I crank it down to 1 kV. Fires every time. What do I know about the crank sensor? Oh, look at this. Cam sensor. What about the ignition module? What do I need? Coil. Okay, scan tool again. We remember the scan tools. Compression vacuum gauge. A mechanical gauge. We're going to tell this, guys. The mechanical gauge is going to give you give you problems. Every car that I look at has got plenty of compression. And you're going to tell me why. And mechanical gauge is only going to do what? Trap the highest pressure. So if the first crank is 140 and the next one is 60, or it goes 70, 110, 140 down to 30, are we going to catch the 30? Absolutely not. And with the vacuum gauges, I can have a valve that doesn't rotate, stuck between the exhaust and the spark plug, doesn't rotate, looks like a plasma cutter, cut a 1/4 inch by a 1/4 inch off. I got 19 inches of steady vacuum. Manifold's about a foot high. Those intake manifolds now are basically a vacuum reservoir. It's like taking a pebble and trying to knock the guy off from the canoe with the in a lake. He's on a canoe, and you go, and you're trying to take a little rock and skip it and flip the canoe over. You can't do it. And if you use a vacuum gauge and you're able to use it to get good information, it's got to move. If it's too damp, it's no good. And again, the late model engines are so large. That is 19 inches of steady vacuum. That engine was jumping out of the cradle. Out of the cradle. Got to use scopes, plenty of scopes. Modern Misfire, I got the Misfire detection. Every once in a while, I'll just make sure my scan tool is right. But if we have a misfire on a cylinder, what's the quickest way we're going to check it? If I turn around and plug out cylinder number 6, if I pull off the plug, take off the ejector of the coil, it should do what? It should not change. If it changes, it's not that one. I just don't know why we're going a little further. But I threw it on here. Cylinder number 2's got what? A constant miss. Pressure transducers, positive, negative. You got to buy both. You got to buy both. I have to buy another trigger for the exhaust. When I do a pressure transducer, I want to do the inside the cylinder, I want to do the intake, the crankcase, and the tailpipe. The only problem is the tailpipe's got a trigger, an H2O trigger on it, but I use that for the crankcase. So I got to buy. But the waveform, just by pulling the plug out, it'll tell us the compression levels, if the valve's opening and closing events. It'll tell us if we have 10 inches of vacuum. It'll tell us if the exhaust, the intake valve timing is on. It'll give us exhaust restrictions. How many days do we used to pull out the O2s? What do we take with it? The threads. And then what do? We look this way, right? And then we get it halfway on, we start hammering the crap out of it, and then we make a little wig welder or JB weld, what? Anti-seize on it. I used to cut those notches in them, but I like the Ford Explorer, right? Let's put that against the firewall. And the Volkswagen for 23 years, it's like, okay, drop the exhaust, I gotta change an O2. They put it right against the floor. Ignition injector timing. Can we check that real quick? Really quick. We already saw that. But the fact is, if you use 2 instead of 1, we can put it on the intake, and if I get a misfire, and I get leakage in the cylinder, if I get on the intake, every time that piston goes up the top dead center, if I get a leak going through the valve, what's going to happen to the pressure? Vacuum pull, and then when the piston goes up, the pressure's going to go up. So right away I could tell if the intake's leaking. How much more time did that take? I popped off a central hose. Most time the central hose, what? Brake booster, PCV? Real quick to get to. Forget about the plastic ones. Just break them. Now, to look at the waveform, I mean, if I look at this, and you're playing with it, and thinking about VVT, but if we start playing with that, that's a lot of noise. That's a lot of looking at it, trying to figure out the degrees, coming down the bottom, looking at the duration, 230, 232 degrees. It's a lot easier just to look at this waveform. Because at this waveform, I can look at this, and you guys will learn it too. We can see the compression level. We can know with the exhaust valves, all the valves are opening and closing. We can check to see if the valves are recessed, if there's a sealing issue, whether we have a carbon issue. We can check for a blocked exhaust just by looking at that. And a couple of things. Caution, leaning towers. Crank and compression tests especially. If you view leaning towers, possibly mechanical issues in a cylinder waveform, make a comparison with another cylinder to be sure there's a mechanical issue. Just because you see a lean. If I do a running compression, I pull a hole out. I got throttle by wire. Can it kick up to 1100 RPMs? If I put more air into that cylinder, will it look like I got a leaning tower? Yeah, it will. Just understand, I'm finding, I talked to Bernie the other day, I'm getting some cars right now, new cars, where I'm cranking them over, and I'm getting leaning towers. I've only found 2 models right now. So, but I notice when I do running compression, if I can get the idle down to 700, the leaning towers go away. And a lot of times, if you try to do the snap throttle by wire, I'll take a Honda, I'll put the transducer in the hole, and usually when you snap a throttle, when you have a cable, we'll get 3 times the pressure we do at idle. That snap, when I get that big burst of air. When we got throttle by wire, it's being controlled by the PCM. I'll snap, a lot of times I only get twice. When I take a car for a ride, customer will bring a car to me, well, the shop, I don't go to the customer. They'll bring a shop. The customer only cares that they're driving down the street and the car goes 30 miles an hour. And you'll say, well, we go up and start the car and you can feel the miss. And we'll say to the lady, did you notice the light flash? Yeah, but the thing only goes 30 miles an hour. That'll drive you crazy. I won't drive anymore, fix it. And they don't realize the two are related. But if I got a dead hole and I got a 4-cylinder car, can the PCM limit the amount that throttle is going to open? It does. It does. Rising, so we're going to look at this, and this basically is in your book too. It's going to tell us the timing. With the late model cars, I'm finding right now multi-valve, multi-cam. The middle one says, I gotta get a clapper. Right here is basically, if you got a turbocharged engine, supercharged, whatnot, you can be a little bit, you can be right about the top right here. What I'm finding with multi-valve, late model, multi-valve, multi-cam engines, that the exhaust timing, which is the 0 degrees, then you got the exhaust valve opening, 40 degrees, 30 to 45 degrees before top dead, and then as long as we have 10 inches of vacuum, we're going to see actually precise timing. The exhaust is actually advanced 15 degrees. I don't want you fixing it. I'm finding that to be normal. Found that a few years ago. 15 or 20 degrees advanced. It's normal. It's normal. Another thing, I have a guy, you got a chain in a car. Tell me what's wrong with the car. I come to your shop, the valve timing's off. You take it apart, you line up all the paint, you get everything where it's supposed to be. You put it back exactly like you took it. And they go, Dave, we put it exactly the way it was. Is the problem gone? Yeah. I want to come down and show you. I put a pressure transducer, everything's lined up perfect. What was wrong with the car? The tensioner. Now, if the tensioner's got a problem, do we need to talk to the customer? If we're changing the oil at 15, 20,000 miles, how long is the new tensioner going to last? They're just going to be sticking again, right? So again, late model engines, they can be 15 degrees, 15 to 20 degrees on the late models. Again, here's the exhaust. Variable valve timing, we can, instead of being 20 degrees after the overlap, we can be 30 degrees over the overlap, and that's normal. That's normal. I usually see that with the Volkswagen Audi GDIs anyhow. They're about 30 degrees retarded. But VVT can go up to 30 degrees retarded. That's what I've been seeing. Here's a running compression waveform. Here's a good one. Exhaust valve opening, exhaust ramp, intake valve opening, intake ramp right there. How many inches of vacuum do we need? At least what? 10 inches. Exhaust valve closing, intake valve closing. Now, if we look at it right here, and we look at this real quick, I only want to puzzle this. It's not a pressure transducer waveform. But on a regular aspirated motor, his bottom dead center, that ramp was supposed to be in the middle, right? Was that ramp supposed to be in the middle? It was, let's just say it was supposed to be in the middle. Now, I just said the exhaust should be, the middle of that exhaust ramp should be 20 degrees. If it's got VVT, it can be 30 degrees after top dead center, over valve overlap. So 30 degrees is right here. Each one of these is 30 degrees. This is 30, and this is what? So this thing's off by how much? They're both off, right? They're off about 40 degrees. Is that a power problem? Is that a misfire problem? Real quickly. All right. That's where they are. Okay. Now, this is lined up. And I don't want to, this is a 2-year-old car. It's got 15,000 miles. I get called because it's got a P0305. I get the tech taking it apart. One side's off almost 25, 30 degrees. The owner comes over. He's a close friend of mine. He's a guy that's just been working the business too long. I got the guy taking, I forget what kind of car it was, but he had to take the covers off to pull out the coil. I get him taking the coil the other side. Dave, I only paid you to diagnose the injector because we've changed everything else on that cylinder. So the service manager, and Ricky's going on and on and on. I go, Ricky, calm down, you're going to have a heart attack. I'm telling you right now. He goes, I go, the timing belt's off. I want to see how much it's off from this side. No, the car's 2 years old, it's got 15,000 miles. Impossible. I go, Rick, I'm in Volkswagen Audi Tech. We're changing motors at 1,000 miles. We're putting trainees in every 30,000 miles. Your spark plugs, oil change, and a trainee. Okay, here's one side right here. Here's the marks. Again, here's the mark, and here's the lineup. Here's the mark, here's the lineup. Understand, the PCM picked out one cylinder. Now, this is one side of the car. The other side's worse. So the service manager comes out, and Ricky's going on and on. I go, Kevin, let me ask you right now. I'm going to tell you what's wrong with this car. This car doesn't go over 40 miles an hour max. He said, Dave, you're wrong. It doesn't go over 20. Ricky goes, you're just trying to get another hour out of me. The way you act up. Now, I'm going to be honest with you. Let guys go on and on. Let people carry on. That's a fine. I charge extra till I feel good. It could take a year. But some people need to know. And they need to learn, and some people are slow learners. You know, my buddy gets $160 an hour. Why are you charging me $190? It's a fine. You're here when I show up. It's a fine. Okay, what's wrong with this car right here? We go to top dead center, right? We compress, decompress. What's supposed to happen at 30 to 45 degrees before, I'm just using that as an average, before bottom dead center? What's supposed to open? If it doesn't, exhaust valve doesn't open, what's going to happen when the piston goes to top dead center? It's going to take whatever's in the cylinder and do what with it? Okay, these are up here at 57 and a half. This one's down here. Why? What valve opened? Intake. This car was getting a motor. How many cylinders are misfiring? If I take 52 pounds and I put it in the manifold, they're supposed to have 20 inches of vacuum. Every cylinder went down. So, can an exhaust valve not opening affect other cylinders? I see all the time. This can be junior over revving the car in the rocket part. That's how I fixed this. $30 worth of repair. It was a big old V8 Chrysler. And I go, grab that bar that I can't lift. I want you to push down the valve. Put air in the cylinder. He pushed back the valve. What did I do? Took the new rocker and what? After lifter and put the new rocker, I whacked it in place. I just, if Junior drives it, just put an extra couple of quarts of oil in it. Maybe more pressure will keep it in. I had an intake, kid come in, 16 years old, came to the dealer. And the guy was mad. He had a Scirocco, V6 Scirocco. We put a V6 in a car that weighed 1,400 pounds. So he come in, guy's mad. Huge dent in the center of the hood. He wants it fixed. He's going to sue. But I walk around, the right front tire is bald. Bald. What's Junior doing? Guy goes on and on and on. I go, let me tell you something. Are you done? Are you done? I'm going, how can I find this guy? He's under warranty. I'll figure a way. Then he finally stopped, and I looked at the wife, and I said, how old is Junior? 16. Go to the end of the street. Tell me if you see all these long black marks. And that, by the way, it's about 1,400. Those are hydraulic model mounts, and he snapped all of them. Okay. Now, look at this. Now, this is a running compression, and I want to bring this up. Right here, that's scavenging. When we turn around, when we got the piston pulling down on 360, what are we doing? First of all, when the piston comes up, what are we trying to do to the exhaust? Push it out, right? And then when the piston comes down and the intake opens, what are we trying to do? We're trying to pull the charge in. We want the volume to come in. Volume coming in the cylinder is going to make the pressure, right? Volume makes pressure. That's the only way it works. So we're trying to draw it in. This is a turbocharged car. Me and John about 6 years ago figured out that this was normal. Okay, that's normal. Now, car comes in over and over. They did a 60K. Comes in, it's got a Misfire PO301. And, oh, he stole this. Dude, drive me nuts here. Gee, you got rid of half my slides. Got a PO301. There's no nose. One side of the motor looks like this, the other side's got no nose. What's wrong? Timing's off. PO301 is both, it's a Subaru Legacy turbocharged. They had the timing belt off twice. They told me dead nuts. They put plugs, the coils, injectors, everything. I said, dude, I put a transducer in. One side I got a nose, the other side I have no nose. It's got PO301. What about the cylinder next to it? How come we have Misfire in one and not in the other? We can't. The PCM couldn't what? Identify the other cylinder. So we did. It needs a timer. I had a colored picture of each one, and he took it. That was going to cost him 20 minutes. Okay. What do you notice about this? Okay, the exhaust plateau is going to be plus or minus 1 psi. But if you've been noticing, the plateau can have all these oscillations in it, but it's fairly what across? It's fairly what? Flat. What's happening here is if you see these go up and up and up and up, what are we doing? Every piston that comes out on that side of the bank is doing what? It's pushing in. It's going in, going in, going in, and the pressure's rising. If I had a 12-cylinder, a V12, it'd be up around here, right? So what's wrong with this? Blocked exhaust. Now, we normally, let's just say that's a normal pattern, okay? If I snap the throttle, so every time you do a running compression, guys, you've got to use pressure transducers. I want you to snap the throttle every time. When I snap the throttle, will I see the intake valve timing or the exhaust valve timing? No, because is there any intake vacuum? No, I get the throttle wide open. It's going to be 0. So it's going to come down. It's going to go right across flat, right? More or less flat. If it looks like that, what's wrong? It's pressure. It's a blocked exhaust. Blocked exhaust. All right. It misfiring on cylinder 1, 3, and 5. You took that out too. Okay, so basically I just put a thing in here. And what we're going to do is, I'll show you after lunch, after break. We'll take the bottom of here on a snap. We're going to go over 60 degrees, 30, 60. Every one of these is 30 degrees. We're going to put a line up here. The highest pressure between here and here at 60 degrees, whatever the bottom of here and the top of here, anything over 10 psi is a blocked exhaust. But you'll notice it's going to look like that on a snap. Should it look like that? No. There's no vacuum, right? We're going to snap it hard. There's no vacuum. It's just basically 0, right? It's not absolute pressure, right? So we're going to read 0. That's the restricted exhaust. Okay, normally aspirated engine. What's wrong? What has a nose? Turbocharged. Should that have a nose? What's wrong with it? Valve time is off. Now it's got intake and exhaust. That's on the exhaust. What's the relative compression look like? Could it be good? It was good. He stole the thing. Bastard. Okay, turbocharged engine. What's wrong? No nose. Keep it simple. Right here, it's off. But again, it's both sides. New timing belt. PO301 failed test. How many cylinders are misfiring? Both cylinders. Checking ignition time. We know that I can turn around and put a cursor right here. See, I put the cursor right here, and I line it up right here, and I can tell how many degrees. Can I now check that with my scan tool? Yeah, so it's real good. This is, I did vacuum and cylinder pressure and vacuum. I call this ugly. This is a 5-4, broken valve spring. Basically, the vacuum's following the pressure waveform. Crank and compression test. Can be used for engines with very unstable idle. If that idle's going up more than 300 or 400 RPMs, you ain't going to get it. Your waveform's not going to be really usable. So I want you to do is do a crank and compression. If you have a mechanical problem with running and you want to make it more exaggerated, do a cranking. Every time you do a compression, I want you cranking, running, I want you to do a snap and decel. So if you have a mechanical issue and a running compression test more pronounced, do a leakage test. It really gets exaggerated. Because what happens during cranking that doesn't happen during running? More volume, more VE, right? More leakage, pistons moving smaller, as well as a nose stop. Crank and compression. Issue? Retarded exhaust valve time. Now, this is a crank and compression. I get a misfire cylinder. Now, basically, these should be fairly, this the bottom of the exhaust and the bottom of the intake should be even. I give it 3 pounds difference. Any more than 3 pounds, it's 2 to 3 pounds. I'm real pain in the ass with that. 3 pounds, it's a leak. It's a leak. How many, got 52 pounds during running, this is cranking. Cranking, we need a minimum of what? 100 pounds. 100 PSI. We got to break the hydrocarbon chain. We got to rip them molecules apart. So what happens when it's 2 minutes? You give me the 2 middle fingers? Yeah, okay. Guys from New York, you Yankee fans. All right. Hey, Belichick's weird, but he don't look at toes. All right. So, that's all I'll say. 9 3/4 PSI. We got a leak there? We got a leak there? We got a leak. Now, basically, I use modern tools to find it real quickly. It only took me a sec. If that is underneath the manifold, what do? This car had 30,000 miles. 30,000 miles. Nissan says a 2009 Versa. I looked at it 2009. They ordered a cylinder head. 6 weeks later, she still don't have a car. They had no rental for her. They took it back after a month. She wanted to go to New Hampshire. She said, can I go to New Hampshire? I'll ruin the car. So I do a channel number 4 running, cranking, and I do a cylinder number 3. To do 3, I have to have the guy pull the manifold off. I find a huge leak. So the next thing I do is I put my borescope down. And I put it down. Piston's at the top, right? I always put a TDC indicator, make sure it's at the top, make sure the valves ain't open. I put the borescope in. It goes down, it goes down, it goes down, it goes down, it goes down. I go, my God, right? I think it's collapsing like an accordion. I yank it up, the light, I can't see it anymore, covered with oil. Hey, when they put a head in it, have them put a block in it too. There needs to be a diagnostic process in place to find the root cause of any complaint or symptom. Misfire detection is no different. There will be times that you will be able to quickly diagnose the root cause of a misfire. Other times the root cause will not be as obvious or evident. It'll be hidden. 70% of an injector flowing. The valve spring's broken at the bottom of the top will act up over 3,000, get back there, 3,000 RPM. They won't do it at idle. This is where diagnostic process is another good tool which is advantageous to you to ensure no system or component is overlooked. Now I want to show you some process. It's the same diagnostic process, but it's got different directional paths. This is the one I use the most. Engine misfire, PCM, engine management, ignition, compression, air, fuel. PCM, I'm going to do basically what? I take the car, I verify it. It's got a misfire. Lights flashing. Do I feel it? Is it a vibration? If I don't feel it, and I don't feel a vibration, am I going to play with this? Am I going to take anything apart? No, I'm going to stick my head in a TSB. I want to make sure there ain't a crank relearn. I want to make sure the test is not something that I got to reprogram. I don't feel it. Can it still be a crank or cam issue? Can it be a cam or crank that has any kind of imperfection or abnormal in the waveform? Yeah, it can. It can. Then, so now I go to engine management, I'm going to use my scan tool, right? But I'm going to verify anything that says on it because I don't going to trust it. Am I going to make sure the cylinder's right, that's identified correctly, the one that I'm working on? I'm gonna. I'm just waiting for the person to come up. Then, if I'm going to, I want to check ignition. Well, when am I going to check ignition? If the cam and crank's right on, and I got a misfire, and I got it on a cylinder, if I pull the plug out, and I check the ignition coil, and if I don't get 35, I want 35 kV I want 35 kV at atmospheric. That's my minimum. If it's at 14.7, if you can't jump 35 volts at 14.7, are you going to jump it when it's 150 pounds? Are you going to jump it when it's 100? Absolutely not. Absolutely not. And then I'm going to check the plug, I'm going to check the coil, and then I'm going to put a transducer in there. But the last thing I'm going to do is the air and the fuel. The air and the fuel. The previous example showed different directional paths for the same diagnostic process. There was 4 in here. You got 4 in your book. Basically, it's, you get in there, you know it's ignition, you know it's fuel. You're not going to, the diagnostic sheets are set up for that first one. Because those are the ones that when I go to a shop, am I getting 2 days to work on this car? I'll get 2 hours minimum. And I'll be honest with you, I'm a lot higher than the dealers in my area per hour. A lot higher. And I've always been higher. So, but I'm going to get 2 hours. Because they get a minimum 3. And my guys double or triple my labor rate. So I don't care. But I'm not getting more than 2 hours. So I got to need a process and stuff. I'm not going to be jumping around. The last 2 blue caravans had this and that. I don't believe in silver bullets. And I don't believe in good known parts. Parts for cars. Okay. The idea is to keep focused. I want you to keep focused. I want to stick with the symptom. I want to prevent random testing. I want to prevent replacement of known good parts. The car doesn't start. I got $1,200 in. But it's better. I don't get it. I don't get it. Okay. And also to be successful, I'm ignoring you. To take good notes and record all your test results. The car comes back a week later. I want to know if the failure records are the same. I want to know if we're going after the same problem. I want to know if the conditions are happening. In my area, Massachusetts, when that mill light comes on, do they run down and I got to get this light fixed right away? No, they put a picture of an ugly kid in front of the light. And it stays on for 2 years. Examples of directional path. What is this? And we're going to take a break. What is this? Scientific wild-ass guess. They don't work. All right, guys. Hey, the first one's going to be a 2005 Ford pickup truck. We got a couple weeks of working on this thing. This car, a lot of these cars that I've been doing lately with these Triton motors, I'm not picking on the Fords. I have a horrible time. I pick on Ford when I teach classes, and the Ford guys get all bent out of shape. But I explain to them I owe them $98,000 between 2 trucks, and I can call them whatever I want. And they usually leave me alone. I have a lot of problems with these cars, intermittent misfires. These trucks have been acting up lately where the misfires are there cold, and when the car warms up, they're gone. They're gone. The light's flashing, Massachusetts, if the car ain't stolen, it's got to get a sticker. So, this is a 2005. It got a lot of parts in the car. Car's been worked on a couple weeks. I show up, I don't get a picture of the car. Okay, 2005 F-250, customers complain. Engine seems to run rough. After sitting overnight, check engine lamp is on. Technician notes, engine misfiring after cold soak. PO305 DTC stored. Misfires until engine is hot. Misfires intermittently occur when the engine is hot. During the diagnosis performed, they did the basic checks, the visual inspections, checked the compression was good, running, cranking, snap, it was all good. They checked the ignition KV, output was good, injector control was good. So, for what he could tell, I'm thinking he's using a Nord light or whatnot, because he doesn't use a scope. And he replaced the cylinder number 5 injector, and he put a spark plug in it. So, he called me up and he said, "We come down and look at it." He said the customer, it's an F-250, it's got a gate on the back. And they use it. And what happens with this is when it's cold, it's got no throttle cable. The guy don't care about how it runs. He's mad, or he can't drive it when it's fully loaded because he can only go 30 miles an hour down the street. What's happening that he's only going 30? The light's flashing. I don't got no throttle cable. I got no bolting cable. So I'm in what mode? I'm in power limited mode. And he says to me, I got like 6,000 pounds on the back. Oil barrels and everything. He says, who's going to tow it? I don't know. So, okay, so I verified the complaint. I performed the visual inspection. I'm going to check the charging system. The battery's junk. Am I going to do a relative compression test if the battery's junk? No. And I'm looking at the fluids. Are the fluids a big deal? Can I be losing a little bit of fluid? Can I cause a head? I go in and I get more shops. They'll say, head gasket, head gasket, head gasket, because it runs lousy when it's cold. Can it be a spark plug with a tracking problem? When's the highest KV demand? Cranking and what? Snap throttle, boom, boom, boom. And cold, right. So I'm concerned about my visual. And I will ask the guy, if it's low, how much antifreeze you add? I want to know, because I know, especially in the wintertime, it can be masked. Now, this car, it acts up cold. When am I going to test it? Cold. Intermittently, it does it hot. So I only got one shot to check a look at this car. So visual inspection is a big thing. Charging system is a big thing. It's a big thing. When I do the visual inspection of the charging system, what am I also looking for? Anything binding, right? My accessories, power steering, serpentine belt, whatnot. I'm looking for something binding. Okay, I did a crank and amperage test. We're going to call it a relative compression test. I, for years, call it crank and amperage. You call it whatever you want. We need to do this. We know to do this. We don't do this. We need it. So I really want to get you going. I crank it over. I crank it over first, and if the waveform is lousy, the thing starts going up and down, up and down. Dude, put a new battery in. Clean the connections. You got a voltage drop. I want a new battery. I want to clean the connections. I crank it over. I want to fill up the whole screen. Do you notice anything? Let's zoom it in. Okay. Now, I'm going to sink it off the bottom. I'm going to pick any coil. All I need to know is what? Exactly. So I sink it off the number 1 ignition, and I'm going to line it up. Now, here's number 1. So I'm going to count it. Now look at this. Look at this. Like 1, 2, 3, 4, 5. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is it the same cylinder? Now let me ask you something. He does a compression test. It's good. Well, isn't the compression good right here? It's bad here. What does a mechanical gauge do? I'm in the shop. It takes me about 20 minutes to yank my crap out of the car. He goes, well, look at the scan tool. No, I'll find out if the scan tool's accurate. How much time do I get into this car? I'm an old guy, so I fell, I tripped, I talked to the secretary, I dragged the stuff in, I had my leads on the ground, I got to clean them. 20 minutes, right? But my point is this, my basic testing, and then the thing is this, understand, you'll see this. It may be every 16th time, it might be every 32nd time. Is there a problem with this motor? How much amperage is it taking to draw here? It's enough just to turn the crank, but there's no resistance. There's no volume being compressed in that cylinder. Now, why is the next one real high? So the problem isn't here. It's right here, right? That's all I want to do. But we can go up here. Once we know this, we sync it off. All we need to know is the firing order. And we're done. We're done. Now, what can fix that? It needs, so the next thing, I'm just going to do my basic testing, right? I'm going to do basic testing. So, count the peaks from cylinder number 1 in sync. Again, here we go. I go in. Is the cylinder right? Is it doing the right cylinder? It's doing the right cylinder. I'm going to check this afterwards. Not going to check it first. This, I'm verifying that, and then when I plug in the scan tool better be showing me big boobs. Well, I ain't Dr. Noel. He always doing this. I'd rather do this. Okay, but I'm verifying that I picked the right cylinder. Everything I've done to this point is right. It's correct. Okay, now, here's the waveform. Here's the waveform right here. What do we notice about it? I wish this light worked. We don't, right? No. What do we notice? First crank is what? 140. Next one's down here is 80. Up here again. So what's my mechanical, this one's right here, it's about 75. What's my mechanical gauge going to be? Am I going to show good cranking? Am I going to show good running? I am going to. This is where we run into problems. We just got to think modern. I don't care about anything attached to this motor. This car's got VVT. I don't care. It's got 3 valves. I don't care. I only care about what happens when that ignition goes off. Do I have the right compression? Is the spark happening at the right time? Is the fuel there when it's supposed to be? That's all I care about. That's all I care about. Now, that looks fairly good, right? How about that? No. No. So, basically, again, a little further along, I need 100 pounds minimum. I get 85. I get 85. Now, previous slide with the crankshaft degree software. I'm going to put that in. We see all the events happening. We see leaning towers. They're not really that exaggerated, but just seeing the compression alone, we know there's a leak, right? And then we know, I like 3 pounds. So if I put a line across the bottom of here, I want to see what? No more than 3 psi, right? Either way, we got a leak. I'm just trying to figure out how many slides he killed. All right, the intake is red, and the crankcase is blue. So the minute I turn around, the minute I put air in the cylinder, it goes up. If I snap the throttle with it running, the intake red goes down, and the blue goes up. The blue goes up. And there's the blue again. So basically, it goes up about 10 inches of water with just me turning the air on. Fills up the screen real quick, because I'm going at, it was like 2 seconds, but it just went up real quick. Transducer measuring crankcase pressures with leakage tester. It's almost 10 inches of water. Now, this car, the cylinders are all scored on that cylinder. Now, what happens when the motor heats up? The piston's it's designed to control the expansion, right? But what happens when this thing gets hot? The inside, say the flame front's about 2,000 degrees. We keep the coolant about 200 degrees to do what? Right? To keep air. So what happened? Even though that piston ring's broken, what happened? When it heated, it did what? Expanded. So I can turn around. So if I put air to that cylinder, it leaks right out. Now, we pull the heads off. He called me a week later and says, Dave, come on down. I wanted the pistons. I'm going to get the pistons. But if I touch that, this is the digital new Snappy borescope. It works good. I actually brought it with me. But if you take your finger, that's deep. That's real deep. But that's basically the ring broke. And you're seeing it right there. And it just fills up the cylinder. Okay. So, but I'm saying, how much did I need 2 days on that? Did I need 2 weeks on that? He's given me 2 hours. Did we know right away, quickly, what was wrong with this car? Every car that you're going to see for a case study, been in the shop at least 2 weeks. This one here, 2007 Saturn Ion. This guy was like me, I was in the hospital almost 2 years, but off and on for 2 years. This guy's in the hospital. He's a GM guy. Strictly GM. He gets out of the hospital, takes his car, he's driving it for a couple of weeks. The light's flashing. He brings it to the GM dealer, and they said, you need a cylinder head. It's not under warranty. You're not over by miles, because the thing's only got 20-something thousand miles, or 30,000 miles, but you're over by a month on time. And because Saturn, do we do Saturns anymore? No. So he has to pay $250 to diagnose it. He's mad because I saw his repair, his paperwork in the car. Every oil change, every tire rotation, everything was in there. Every time he brought it was in there. So I looked for something that was irregular. Some problems or whatnot, flooding, right? Nothing. No problem, no training problem, no nothing. No tensioners, no compressors, nothing. So he turns around, it's the 2.2 Saturn Ecotech motor. So he wants so they tell him, because we're not going to pay for it, you're looking at $3,500. So he goes to another shop, another GM shop, but in the next town over, and they look at it again. $200 You got sticky valves. So the guy he was so mad because it wasn't really covered, so he goes to a local shop that he knows, and he said, look, I want you to I don't want to pay for diagnostics. I want you to change the cylinder head. The only thing I want you to use, genuine General Motors parts. I want factory parts on this car. Nothing aftermarket, on factory parts. So they got ahead, they did the whole 9 yards. Mike says I can fix it, I can do it for about $200. Everything. They put it all back together. The car, the problem is the light's flashing. It's at 725, 730. It's flashing, it's storing a PO302. We can't get a sticker, it needs a sticker. I get in to verify it, I can put a cup of water on this thing. I can bring it up 50 to 75 RPMs and the light stops flashing and it's gone. I can clear the code and keep it at 800 and there's no problem. So I come in and before I get there, okay, the car's got 32,000 miles, so it's out by a month. Custom, no lights on, illuminated dash, PO302 failed test, stored memory. The vehicle is diagnosed twice as needing a cylinder head replacement for sticking valves. So I go, well, is this a known problem? You know, I've been out of it for about a year and a half. So I go, and I'm back part-time, and I go, about 6 or 8 months ago, so I go, let me look at it. I do a TSB search on this vehicle. I go, and you know what, when you get a Denafix, it goes a couple of years either way, right? Same model, plus or minus 2 years. I go through the information, I find 2 vehicles with a 2.2-liter. One's diagnosed, both were diagnosed with head issues. One was a burnt valve, the other was a bent valve. Nothing about sticking. Nothing about sticking. Car's got 32,000 miles. The guy's changing the oil religiously. This ain't a Hummer. This ain't that 6-cylinder, the Hummer with the H2. It's not, right? It's not a car that has problems with sticking. I can't find anything. So I go, Mike, we got to diagnose this car. They put a cylinder head in it. Again, all manufactured parts. They put a number 2, they swapped the cylinder number 2 spark plugs, ignition coil injectors. They were transferred to adjacent cylinders, one component at a time. The complaint is still present. Where do we start our diagnosis? From the beginning. Started from the beginning. Performed a visual inspection. Found no obvious reason. If I had a component binding, would it be a specific cylinder or a random cylinder misfire? I have a specific cylinder. Check charging system, accessory drive components, AC, power steering, tensioner, everything. No obvious problems. I bring up tensioners, and you have no idea. I'll go to a shop, it happens twice a year. They'll change the motor, and they go, Dave, can you look at the motor? The new motor, or the used motor we put in, is locked up. So I'm thinking there's a chunk of carbon between the piston, not letting it go up. First thing I get there, I say to the guy, take the belt off. I go and move the belt, and I'm an old guy, but I should still be able to flex it, right? I said, dude, just cut the belt. It's brand new, I don't care. Cut the belt off. It goes click, click. Cuts the belt off. Whoa, 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 whoa. And I go, if it can stop a motor from turning, can it create a misfire? Can it try to, what's basically doing is pulling on the crank. Pulling on the crank. No obvious problems found. Check data pins, key on engine off, key engine running. Found no data pins out of normal operating parameters. Check misfire data, current history and misfire graph. Okay, here's the data pins. I'm at 762. I got 6 misfires. History, I got 34. 34. Again, I know he's cleared it probably an hour before I got there. The light is flashing right now, and it's counting misfires. I bring the car up to 8, I bring the motor up to 844. How many current misfires are there? None. Now, let me bring it up to 1,800, 1,756. There's no problem. I can put a cup of water on this. It ain't moving. It ain't moving. So 17 RPMs. Now, cylinder 2, as long as it's idle, it's 773, it's going to walk across. It's going to walk across. Not very fast, but it's going to walk across. Fuel trims. Short-term fuel trim, 0. Long-term fuel trim, 5. Got an issue? Don't get an issue. Got 102. A lot of times with misfires, I'm going to be honest with you right now, you can't, when my experience, if we got a Type A misfire, you're not going to be able to use fuel trims. What happens to fuel trims when that light starts flashing? What happens if we're using Lambert? Lambert 1.0 is what? Broke. 1.0 is broke. 1.0, all operating ranges is telling us what? The car's in what? Open loop. That's what it's telling us. So if I got a Type A misfire and the light's flashing, the light should be flashing. It should do what to protect the cat? If it can get that cylinder, it should do what? Shut the fuel out, right? We're gonna take the fuel away from the cat. Now, if it takes the fuel away from the cat, what's it gonna do? It's gonna go in open loop. It's gonna get an open loop. We don't want any correction. We want to bring it back to where it's an open loop and we're using an RPM load and speed chart. Fuel trim, learn, enable. That's General Motors' way of saying we're in closed loop. It's learning. We're in closed loop. Use misfire detection software to verify cylinder number 2. Now, really quickly, we can check it, right? I don't really want you touching if it's a bad connection or terminal tension or micro-threading or either the coil or the injector, I really don't want you touching it. So I got the misfire software, I'm going to put it in. But how can we quickly check? If we went to check it, we could just verify that's the cylinder, right? The PCM is only detecting cylinder number 2 misfire at idle speed only. If the idle's raised to 100 RPMs, it's gone. The engine is not running rough, the misfire is not felt, even in gear. With this information, where do we start? Let's check the 4 primary circuits for proper operation. Okay, I got the crank up there, I got the cam, and I got the ignition control. Do we see any anomalies in there? There's no anomalies in there. We got to crank through this. All right, here's injector for number 2. There's the cam sensor is red, it's underneath the yellow. Yellow is very dominating color. So I got the injector firing, the cam is still there, crank is still there, it's working. I'm pulling it down, and you see the bottom here. I got counter voltage going on right here. See how it goes up? I know there's amperage flowing through that injector. I know there's amperage flowing through. If it's flat across, all I know is the drivers pull the supply voltage down. That's all I know. But the fact I can see the bottom of the upward curve, I know I got counter voltage. Now, I'm gonna move around here. I checked the cam sensor. I got rid of the crank signal because it's dominating. I got a cam sensor, I got the injector, and I got the ignition. Do we see any problems with that? No, everything's there. There's no anomalies whatsoever. Drop it back again. Here's the injector and the ignition control. Ignition only goes up to 5 volts to turn the coils on. Then I do a crank and compression, crank and vacuum. And I got a good pull from cylinder to cylinder to cylinder to cylinder. One cylinder to the next, to the next, to the next. I got a great pull. So that tells me basically real quickly, what do I know about the cylinder? It's good, it's good. It's tight. Okay, our testing has revealed the cam and crank correlation is correct. The ignition secondary is capable of 30 kV. The injector firing is at the correct time. Good vacuum transition from each cylinder. With this information, what should be our next test? Let's get into the cylinder. We got to get into the cylinder. There's something going on here. Would a burnt or bent valve only create a misfire issue at idle? So we can get rid of those things, right? The only 2 cars. They probably sold 1.5 million of these cars. It's a Saturn though. Probably that's a Volvo after a crash test. Could sticking valves create a misfire issue only at idle speed? When do you see a misfire, sticking valves? You're driving on the highway, car's got low maintenance, you got mud in the car, you pull up to a toll booth, and the car, you've been running. Don't the valve start to stick? And it's usually crud and all that crap in the motor. That's when I see it. That's when I see it, after long speed. What possible component failure could create this vehicle complaint? Can't get a sticker, he's paying $3,200, and now he's paying me. What is the next and possible final step? And it's going to be the pressure transducer. Here's cylinder 2 running compression. Okay? Let's put the degree in there. I'm going to tell you everything as far as the valve opening, closing, timing, everything's correct on this, on cylinder number 2. Let's take a good look at it. What's the 4 things that a transducer will tell you? What's the first thing? Okay, cylinder number 2, running compression. Do you see anything mechanically wrong here? I'm going to say no. Okay? Cylinder 2 running. Okay, here's cylinder 3 running. Same thing, absolutely nothing wrong. Do you see anything different between the two? What's the compression on this? 102, right? What's cylinder number 2? 57.5. Now, it could be a valve seating problem. Valve seating, recessed valve, valve seating, I'm just going to cover it real quick. If we see if this doesn't come down as a curve, if we see any deflection in here, any straight line, and it's the same from one cylinder to the next, one event to the next, to the next, to the next. Same thing with the intake closing. We can say it's a valve seating problem. I do see a little imperfection here. I do see them if you saw the whole waveform, but it's not every time. If it's not every time, that's a brand new head, and basically the valves ain't what? They ain't broken. This car doesn't have a mile on. The car doesn't have a mile on. But how many running compression, what do we have? Okay. So we see the difference. But the waveforms are mechanically perfect. Valve seating issue. See the waviness right there? See how it flattens out? That's a valve sealing issue. But look at the next one. It's gone. If it was there every single time, it'd be what? A problem. Is that creating the misfire? No, it's not. Changing valve opening, not repetitive enough to create a misfire. Now, here's the difference between a mechanical gauge. Cranking, I got 175. Problem with the cylinder, I got 130. Running test, I got 75. So you see the pressure is off, a difference about 20 psi. Now, we're trapping the highest pressure, but with the transducer, we're taking volumes or columns of air and we're putting it in the cylinder and we're watching the change. We're not trapping anything. So we got a difference of 20 pounds. But is it still showing us the bad cylinder? Okay. Do a leak down test. I did 40, 60. 60 is the most you can do. Actually, I can do a little higher than that. 60 is what you want. If it's V6 or V8, the crank will turn. But if you put it on top dead center and use a TDC indicator and you push it straight down on the crank, you can usually get 70, 80 out of it. The most I got, look at this, I'm putting 39 into it and I'm holding 41. Hey, it's Mac. Okay? So, what has our diagnostic test revealed so far? The compression test revealed that cylinder 2 cranking is approximately lower. The running test reveals cylinder 2 is approximately. The cylinder leakage test shows no leakage at 40 psi. When the supply pressure was raised to 60, the cylinder pressure loss is approximately 1 to 2, wasn't 2 psi, just over 1. Is that a sealing issue? Absolutely not. Now, to get it there, am I sticking a screwdriver down the hole? Oh, that's great with the 5/4s. Everybody does that. Dude, take the valve cover off. I don't have an adapter for TDC to go in that hole, 16 millimeter by whatever. Piston's like this. Where's the plug? Like this. Where's the screwdriver hidden? That piston's down about an inch. Every time we do it, the exhaust leaks. Take the valve cover off, turn it a little bit further, then there's no leaks. Okay, is there anything mechanically wrong with this motor as far as sealing? Okay, the pressure transducer for cylinder number 2 showed normal valve opening closing correlation with the crankshaft. The waveform detected some valve seating issue, but not repetitive enough. Cylinder leakage test revealed good cylinder sealing capability. With this information, what test would be the last step in our diagnostic process? Only one more step. What's that? That's a TDC indicator. I get done with the car, I go, what am I missing? What am I missing? About 2 hours in the car, I'm going back and forth, I talk to myself. I have a notebook, 5-subject notebook, I fill it once a month. I take about 300 pictures, I drive these guys nuts. My wife saws it open one day. It was on the counter. She goes, you swear when you write. What are you talking about? And on the bottom, I go, no S, no S, no S, you dumbass. I'm calling myself names because I've been worried about, I walking around, I go, what did it? I go, dude, I'm going to lunch. I'm not going to waste any more time. I'm going to go to lunch. I get halfway out of the shop. What am I looking at? What am I using on cylinder number 2 to make sure that piston's at top dead center? I'm using that. Okay, so it's at top dead center. Count the graduations. How many are there? The spring loaded, right? So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just over 10. By the way, who's guys party last night? My hand is not shaking. Just let you know, it's you, okay? It's you. All right. Now, this is, so we got cylinder number 2, 10 1/4. Count the graduations. We all passed math, new math. 29.84 millimeters, 1.174 inches. I measured it. Count the graduation. Cylinder number 3. 2 and 3 come up together. And I go, you nitwit, why did you do? I walk back in the shop. I go, don't even talk to me. I take it out. I find out the 2 cylinders go up. And I go to the next cylinder. All I had to do is bring it over here. Count the graduations. Okay, so that is spring loaded. As the piston comes up, it does what? It goes up. So, if we look at the waveform in your book, and we look at page number 49, and we look at the top of 0 and top of 720, that's the compression level, or what? It's the height of the piston. It's the compression level or the height of the piston. What's wrong with this car? Got a bent rod. Got a bent rod. So, now you got to verify it. So he pulled the head off. 2 and 3. 2 and 3. Basic testing. No, seriously, right? Did the transducer eliminate a lot? I'm an old guy. Volkswagens, I did Volkswagens when I was 16 years old because the juniors and seniors wouldn't go to the dealer. I went to the dealer. So for 3 hours, they had to be good to me. For the next 3 hours, I was a slave. They locked me in the trunk. They did water tests. They did road tests. I looked for squeaks. I come out and throw up every day. And, but it would only take me about a minute to take the timing cover off. These timing covers, can you get them off fairly quickly? Hell no. I don't know how you guys get the belts on. Every year you come up with another serpentine belt tool. You got ones that use it 3 bays away. Oh, the ratchets click. Can you step on that? I mean, you got an inch between that, the belt and the shock tower. Are you going to pull a cover? What if it's a chain? What's in there? Well, if it's a Honda, it's no oil, right? It's air in the VVT code. You own a Honda. I'm sorry. I knew it was going to bite me. What? Yeah, that's what. So I called the guy, and I said, I went through all the records. What am I looking for? Fuel injector. I'm looking for a PCM. I'm looking for a fuel injector. I'm looking for something that went in there and bent that. So I called the guy up. I says, he just got out of the hospital. He was in the hospital again. I go, it was funny. I was going in for a week. He was going for a week. I called him. I said, dude, I got to talk to you. You went through a puddle. He goes, yeah. I go, you ruined the motor. No. He goes, you're wrong. He goes, they towed it to the shop. It took nothing to start it. What'd they do? Took the plugs out, cranked it over, put it back in, and shipped it. This bent the rod. It bent it straight down that beam, and then it twisted it, like that. So, I diagnosed the car, and again, got to use gloves. Fresh out of the hospital. Them things are dirty. I walk over to the safety clean tank, and I start cleaning it off with bare hands. I ain't allowed in the shops. Owner comes out, nuts! Stop! He's screaming, what are you, moron? You go nuts. I think I'm fire rate again. I'm just sitting there cleaning away. No gloves. So I turn around. That block had, that engine had, it was all aluminum, had like a $600 core. He calls up, he goes, the guy who diagnosed, he goes, the guy wants the pistons. I got both these pistons. And he goes, what guy? He goes, the computer guy? And he goes, yeah, give him whatever he wants. I'm like, yeah! So I got these. And, but again, you'd be surprised what water will do. John probably covered it. I got a lot of, I was telling John, I get a lot of GDI cars that the injectors don't snap off. They don't. They called yesterday, the other day, they had a caddy. I was like, oh, I just got up too late. They had a caddy, and this is what I see. The gas is pouring out the tailpipe. Right? And it's like, so they went to the dealer, so I call him up, and I drive my guys nuts. 2 hours, he got to my house 2 hours before he did last night. We're in my garage, my wife's new car. I got 5 gallons of E85. She got 3 gallons of gas. What do you think I'm doing? In a week's time, I will know exactly how much percentage on a bunch of cars, we're going to rent a bunch, that you cannot drive that car anymore because of alcohol percentage. We got 25% right now. And I drive down the street, I step on the gas, I got 28% fuel trim in Richmond. Alcohol, they're saying they're going to 15%. I got one a little while back that I was getting all positive numbers. They threw a math at it, they threw a bunch of parts at it. It was all the way up. The only thing else it could be was the fuel. Understand, stoichiometric, 23%, 21% oxygen, the rest is nitrogen. Now you take the gas. Now you take, went to cars, I drive these guys nuts. I stopped and I talked to an ethanol guy at the booth, and he's an engineer. 45 minutes later, come back, I got the guy writing out the molecular structure of all the ethanol gas. And these guys are going, you're still here? I go, dude, he's looking, I got all these patents, I'm taking them up to my room, I got them all over the mirrors. But it's got a huge oxygen molecule. So we've got a stoichiometric, then we add oxygen. We add oxygen, it was basically for the carbureted cars, the fleet cars. What do? We leaned out the mixture, right? What are we going to do? We're going to add more fuel. Well, you can have huge fuel trims and no drivability issue. 25%, my wife's car was pulling down. So I turned around before he left, what do I have to do? Hide the keys. Junior ain't driving this because he's going to be towing it back in about a mile, right? I got 15 gallons of gas, and I just got 3 more gallons of ethanol. All that will be in that car. But I'll know exactly what it is. And it smells. You should be able to, if it's got too much alcohol in it, don't get the math. It smells horrible. Absolutely. Tailpipe smells absolutely horrible. Just a good thing to know. You got to go looking for alcohol. Because if you get too much water, water and alcohol join together. BG sells a kit. They do a specific gravity, and they add the water. I got a bunch of pictures, but you got to go after the alcohol. If you got fuel trims that are high, no drivability, before you just take a quick gas sample before you start throwing maths and stuff in. Cylinder bore, look at this. Bore is perfect. Bore is absolutely perfect. Any thoughts? Oh yeah, I'd be glad to. And it's a basic tool. Wait, here? It's spring-loaded, so the higher the piston goes up, the more graduations you'll see. And being spring-loaded, when the piston drop was down about 1/4 of an inch. No, when the piston comes up to top dead center, it's spring-loaded. So we're going to have more graduation. As the piston drops, it goes down. All I want to do is, when you look at the pressure transducer waveform, my biggest thing was, realize that's piston height. It's compression level, but it's piston height. Oh, yeah. Yeah, and it bend that right. Yeah, yeah. And actually, VE now, the big thing with VE, I call it VE, but understand, we got to know what good numbers are. If at sea level where I live, at 600 RPMs, 10 PSI of basically intake pressure, that's 30 kPa, 30 inches of vacuum, 30 inches of pressure minus 20 inches of vacuum, we end up with 10 inches of pressure in the intake. The displacement is 1 or 2 grams per second of displacement. I call it the 50% rule. I've never seen it. So if we have a 3-liter engine, I want 3 grams per second, plus or minus like 2.9 to 1.1. I want to see that for airflow. So if I see a great difference there, it's either a math issue or what? I'm drawing in too much air. If that was sitting down a 1/2 inch, that's a 2.2. If I see that 4 grams per second, can it tell me that there may be an issue inside the motor? It could. I wouldn't take it that far, but just understand that's what good numbers are. That's what good numbers. And I want to do is take, I bought it, I've had it what we got? No, you got me. Yeah, I bought Snap-on. Snap-on. They don't make them. They make them whistles. You want those. And they don't make the little ones. I found out my kid come over with a 350. Oh, Dad, you got to put this in. He goes, the timing's way off. I said, let's find top dead center. So I shoved it in there, and you can't get the little ones anymore. And I told him, crank it over by hand. So he walks by me. I don't pay attention. He turns the starter over. Took it on like this. And it took forever to get it out. And he goes, Dad, I hope that didn't ruin it. I go, I hope you got a hole in your goddamn piston. For $7 or $20, I can't find another one. Oh, hell with his truck. You can put a motor in for all I care. Do what, sorry? Well, I got a short and I got a long one. They have whistle ones. But you just got to make sure that when you get up to top dead center, that there's no valves in the way. Because the 350, that's what I'm saying. It's really, you can't. It's like I use the short ones, and you really can't. It's really for straight up and down. But it's so much more accurate. That bends it like crazy, I tell you. Yeah. No, they do a whistle one right now. It's just the only problem is, well, no, it's the high pitch that would bother me, because I've had the air tools going off so much for 30 years, right? And I shoot guns all the time, and I'll get in a car, and my wife will go, "What the hell's that noise?" I got to get out of the car. I go, "What are you talking about?" And I'll pick up my kid, and my kid goes, "Oh my God, Dad, don't you hear that?" I go, "What are you guys talking about? What, you got a problem? You on drugs?" But I'm using a graduated cylinder there. Okay, so basically, when we find our test results, we got to verify it. Now let's do another one real quick. I want to go through these. Okay, Honda CR-V case study. 2010 Honda, 4 cylinders, got 26,000 miles. Customers complain. No power when driving at times. Customer will not drive vehicle until diagnosed and repaired. It's been to the dealer a bunch of times. Now it's been to a local shop. I get finally called after the 3rd time it gets in. Why does this car have no power when driving? It's in what mode? Power limiting mode. It won't go over 30. I verified it. It won't go over 30. Now, vehicle has been in shop several times. Intermittent engine misfire at times. Seems to occur after sitting overnight. No hot or extended cranking when the misfire is present. When engine is at normal operating temperature, no misfires. I drove this for 70 miles. I had to take all my grandkids everywhere, whale the crap out of this thing. Not one misfire. When I got an intermittent, I worked in the deal for 23 years. I got an intermittent misfire. I go, oh, what's the first thing come out of your mouth? Unbelievable. No, it can't be fixed. Dude, so I'm looking at this cold. Intermittent, my guys, I have to get a minimum of an hour just to show up. So I tell them, and the guys know that, and it'll be 2 hours if the customer wants to have it looked at by me. I don't show up intermittents anymore. So the thing is this, if I'm going to look at this car, I had the guys bring it to my house. I went out, so it's about 18 degrees. I go out 3 mornings in a row, I crank it over, no misfire. 4th morning, and there's no code. 4th morning, I go out, and it misfires for about 8 seconds. And it's gone. Okay? So, and it's no extended cranking. So, first visit, there's a DT stored for a communication error between the EBCM and the PCM. Next visit, there's a pending code for PO300. It was erased. They're using a generic scan tool. I use the Honda. Last visit, no DTC stored and complaint is not occurring. Visual inspection and various tests did not reveal cause of misfire when occurring. With the customer's complaint, technician knows, where do we start with an intermittent condition? We got to stay with the diagnostic routine. But I'm only going to look at this thing cold. And I said, dude, it could be sitting in my house for a week. So I verified the complaint, but not initially. Drove vehicle probably 50 miles when cold startup. No engine misfires recorded or revealed during road tests. No lack of power. What's the first thing that comes to mind when you're given a repair order with an intermittent customer complaint? We already talked about that. Back to reality. What conditions need to be present to have the complaint possibly reoccur? We need a cold soak. Now, car comes in. I knew the shop cleared it. They had to clear it. It was cleared before I got in there. But there's no DTCs. I put 70 miles on, no DTCs. 3 days, no DTCs. Now, again, you can see it right here. First morning, overnight soak. This is when they dropped it off. Second morning, overnight soak. This is actually the fourth morning. Cylinder 2, it's a temporary code. It's 52 misfires. 52 misfires. On the third morning, I have 77. And that's an all-day soak. So basically, what I want to do, we're going to start the diagnosis, but for an intermittent problem, I'm going to baseline a few things, right? So when it acts up, it only acts up at 8, 10 seconds or a minute, whatever, I got to be able to catch it. So I'm going to do some baseline. After the third morning, which is actually the fifth morning, I got a temporary code for PO302. And it was maybe about 10 or 15 seconds it set that. Customers complain is lack of power, technician note intermittent misfire are the two related. Where do we start from here? And I just want to do this because, again, the dealer, what can we rule out quickly? Binding accessory, right? Charging system, voltage drop, excessive electrical noise, EMI. There's no problem there, right? How about ignition and KV? I have a coil that's burnt and leaking. It's plastic hard, you'll see it. You can very rarely see it. It's on cylinder number 4, it ain't even being picked up. It ain't even picked up. Fuel control. How about mechanical? Now, let's rule out a few of these real quick. It starts right up, no extended cranking. Now we know the misfire is staying on number 2, but we have to prove it's number 2. If there's no extended cranking, do we have a fuel issue? Is that injector leaking overnight? No. No, so we can rule out some real things quickly. We checked the 4 primary circuits. They're all good. I got a burnt thing here. And this is the way I want you to check it. If the spark plug, if the coil is in the tube, is it going to leak? Now, notice, this is the way I want you to check it. If I put that out at 35 kV, and I'm holding that up about 6 or 8 inches, is that going to jump to ground? You're going to jump 6 or 8 inches to ground. If I stick that back into the, you can actually see it jumping right there. When it jumps, the spark goes away here. See, it's very lightly. Can you see the spark? You can see the spark. That's cylinder number 4. But I want to do is, I want you to take a test light, or ground, I grab the screwdriver, put a jumper wire on it. Because if I hold that 6 or 8 inches, it's never going to jump to ground. I stick that in the tube, it's only a quarter inch away. Is it going to jump? Sure, it's going to jump. So that's the way I want you to check it. I want you to go back and forth with a test light. Now, I did one of these, I put a bunch of videos on here, but we're not going to see them all. I had a test light. I went up and I put it right in the spark, and the spark didn't go away. What do I know about that test light? There's an open circuit. So the kid, you can hear him, oh, I got an $8 Walmart, you got the $40 Snap-on, look at this. Kills it every time. And this is a Toyota. This car's got brand new coils, and it's got brand new plugs. Now look at that. So I know that test light, the kid's $8 test light works, right? I got 2 leaking coils. I go around, see it? I made that mark. I put a little marker on there. You can't see that. You can't see that. I got 3 new coils, and I got 3 plugs. The plugs will put in. Like within 6 or 8 months. One of them's tracked, and the other 2 they'll leak right like that. That's actually a black marker. That's the way I want you checking it, because if it's going to jump, it's going to jump there. If I put that in the cylinder, if I put that in the spark plug tube, that's how it's going to go. Now understand, if I got tracking on a spark plug, and I put that spark tester in, that spark tester is smooth. If I got a tracking issue, and I put a smooth into where the tracking is it going to track anymore? No, because I took half the path away. So I'll take the light, and I'll come up between the 2, and you won't get any leakage, even though, see if I do it right here. See, I get no leakage, but I sat it right in between the 2. Because, understand, if there's tracking, you got to look inside the boot. You got to look inside the boot. And it's funny because me and Rusty, we always say, I never see bad spark plugs. And now I'm just seeing them all the time. There's tracking, I actually connected the lines. That plug is brand new. That was in a Ford Taurus. That's in a Ford Taurus. Let me get real quick here. See the tracking? That plug, I'll show you the plug that goes with that. They're brand new plugs. There's a coil, but there's tracking. But if I put that adjuster in there, if I put that, and I don't look in there, I'm going to take a smooth surface and that surface, and I'm going to take the other half of the path away. That won't leak. So I need you looking in there. I need you looking for a path. Now this is what I don't understand. Everybody, they'll come up and they'll say to me, it's got to be the spark plug socket. These plugs are like 3 months old. This is out of that 6 months old. This is with the coils, and it's got three coils and a 6-cylinder on that Toyota. Look at the tracking right there. And you saw the coil with it. But they say it's the spark plug socket. Wouldn't the other two be that way? I mean, these things aren't even dirty yet. Touch it. But I couldn't believe that was leaking. And you can see with the screwdriver, if you really look, if the lights were off. But that's cylinder number 4, and that's not even coming up. I get a temporary DTC and wear, too. Okay, leaking test. Okay, I did this. Here's the waveform right here again. We're doing some baselining here, running, cranking. We've grabbed another cylinder for comparison. Everything's the same. We checked for leakage. I don't have any leakage. Again, it's cold. Cylinder leak down test when the complaint is not occurring. Baseline. I stick this in here. I get a maximum 36 hydrocarbon. Can I be picking that up from the garage? Can somebody be spraying hydrocarbons? Can somebody hit the Taco Bell for lunch? That's 36 hydrocarbons. That can be picked up. Third day of, you got it. Third day of soaking. Engine started misfiring, rechecked the primary, check K output was good, shut off the engine, remove the spark plug, install the transducer, start and run the vehicle, then shut it right off. Everything again is still the same. No problem. Before cylinder leakage test, got a problem? Got a problem. Now, I'm going to add, see, now I got 65, 68. Now watch this. This is when it leaks. Oh, it'll come, it'll spit right out at you. Got my kid right in the eyes. Dude, you got to wear glasses. We got a problem right there? Okay, watch this. Here's the gas. Here's when it's leaking. Again, we baselined it, right? Watch this. I start the car. I only got a second to start it. Look at the hydrocarbons. How can the hydrocarbons get into the coolant? A couple times it went like 350, 400. I got my $6,000 gas analyzer sucking coolant out of the radiator. That's dedication. That's dedication. Okay? I used to use mine V-valve. Oh, use a V-valve. Let me tell you something. A gas analyzer is a very expensive shop vac. When you're on top of the gas tank and you're cleaning all the sand off. Sorry? It was full. And I couldn't smell anything. So I go, when I did this, and I got that reading, I shut it off, I go to school on Wednesdays. I'm going to be honest with you. I'm in an electronic lab on Wednesdays, 10 hours every day. I'm going to be there for the next 3 years. I just don't believe I can do drivability in 5 years from now if I can't fix a module. And I can't look. Again, how much information they give you from schematics? They show you maybe just a pull-down circuit or resistor or whatever. That's it. I need to go in the box, look at it, know what it is, and test it. But you know what the best thing is? For $877, add on to the cost of enrolling, you let the smoke out of their stuff. Oh, this is great. Oh, yeah. Can't do that when I get back. Let the smoke out of everything. Okay, look at this. This is what I want you to see. Watch this. That's coolant. Now, sorry about this. I'm trying to follow that trail down. What's leaking on there? Head gasket, right? It's going down to here. I pressurized. I kept the airlift on this all day to create that puddle. I started up. I did smell it. I did smell it. I ran this car for about 2 or 3 minutes, stuck that in the hole again. It was gone. Gone. Not leaking anymore. That is happening right where the head bolt is. So they either, most of the head bolts are stretchable right now, so I'm thinking it wasn't torqued down all the way. 20,000 miles, you should be chasing it for a year. I mean, again, get basics. We did, well, I bought this because it lights up and makes noise, but like I buy all my toys. I tell my wife, it's really needed. It's needed. All right, I'm going to crank to a few of these. This is slowing down. But again, I just want to show you, I don't care. If we got an intermittent thing, we're going to stay only. We're only going to touch it when it acts up. That's it. We're not going to touch it. I don't care if the car sits there for a week. If the dealer can't fix it and the shop can't fix it, I'm not going to work on it all day. After 8 or 10 seconds or a minute, is the problem gone? That's at a head bolt. So what happens to the cylinder head? If I get up to 195 degrees, what's happening to the head and the block? It's all aluminum, right? Well, the block's cast iron, but the head's aluminum, right? Doesn't the bolt expand too? This is when we used to, the old days, I'm an old geezer. We put 15 pellets in that. Block up the heater core, block up the radiator, but it don't misfire. All right, that's what they do. You guys, you young kids don't know anything about points or anything. Okay, okay, 2008 Chevy Malibu. Here's a case study right here. 2008, 3.6 liter V8. Vehicle's equipped with a 3.6. Engine runs rough while driving. Runs good when idling in park or it stops. During the diagnosis, cylinder number 2 spark plug and coils were replaced. The injector was swapped to another cylinder, but the complaint was still present. I was called to confirm that the PCM was defective before the shop replaced it. So we got a brand new PCM there. Okay? So we got about a week into this car. Where would you start the diagnosis? When does it act up? I don't want to take it for a road test. How can I simulate a road test? I do a torque brake, right? I just make sure if I go in reverse, my truck ain't anywhere around, right? Verify customer's complaint. Perform visual inspection. Can't get out of that. Found no obvious problems creating complaint. Check accessory drive components loaded. It's going to give me what kind of misfire? Random, not specific. Check over previous repairs. I look to see what he did. Check module communication. Record all data. PL3 tape failed test stored in memory. Check all data pins. I didn't want to carry on, so I don't want to look at any data pins. I want to crank this along. All data pins within normal parameter. Cylinder number 2. Is it misfiring? Under what condition? What am I doing right now? All right. I'm in what? What is that light doing? Fuel trim learn is what? Disabled. So is there a misfire? Is it really going to help you unless you were graphing it ahead of time? No. So don't always look at that. Here's the car. Now, here's the Malibu at idle. The injector is blue. The ignition for cylinder number 2 is in green. Do you see any anomalies? Every time that coil fires, right after what happens? The injector fires, right? Sequential, right? What do we see? Let's check that again. Here's the correct sequence where those arrows are. What is happening? What's happening? Why do we have multi-strikes coming out of that coil? I mean, out of that injector. It's being, the only way that injector's firing is it's what? The supply is being pulled to ground. There can only be 2 problems with it. Only 2. I don't need 2 weeks. I don't need a week. 2 problems. What are they? PCM or what? Or wire. So I'm loading it. It doesn't do an idle. Right? Here's the PCM. I didn't put the new one in. I get right there. I take the PCM. He's got the PCM out. I go look at, I figure which connector is the middle connector. I start going down, and what do I see? I'm going to lose this. I see this, right? Damage hardened. Look at that bolt. Sorry that it doesn't. It's a stud. It's shiny as could be. Actually, that's clear as day. You guys, too much hemp. Okay. All right. That's clear. I mean, I can see that. It's got 14 threads on it. It's got a 1.25 pitch. Okay, that's clean as could be. So when I put that in reverse and I torque and I yank the motor forward, or put in drive and yank the motor forward, what is that harness doing? There's the stud. Got an extra thing. I don't really need it. Look at that. Damaged wire. Again, it can only be 2 things. Either PCM is going boom, 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 boom. It's confused. And I'd be looking at the crank and the cam. Or what? It's being grounded. It's either being pulled to ground. And so what do I do to it? That's worth an hour. I'm an old guy. I have no ear-operated tools. Dude, that can take a lot of work. Okay, remove stud section of bolt. Hey, that took it out. Repair injector circuit and harness is needed. Cleared failed test. Road test vehicle in low load condition. Problem did not reoccur. Are we keeping it simple? We're keeping it simple. Intermittent misfires. Oh, hate these suckers. Okay, that's counter. So when you look at a coil or injector, I want you to zoom in the bottom. That's what I want you to do. I want you to zoom in the bottom. I want to see counter voltage. I want to know that there's a magnetic field being created in that. I want to make sure that we're not just pulling it to ground. When I have a misfire and it's on a V6 engine, and I will tell you right now, if I even think it's an injector, and it's a V6, and the manifold's going in the back, which injector is going to give me a problem? Which injector is not going to get air? The middle one. The middle one. And I'm thinking, it got an injector. I've tested everything. I current ramp it. Every saturated injectors should read under an amp, under 9/10 of an amp. Okay, we got a V6. I'm reading 3.60 volts. How many injectors are firing? V6 should have what? If I got 4.5 volts for a V6, how many injectors are firing? You can take your shoes off and count. I go to school after 30 years. She goes, oh, you don't have to take math. Lady, I just want to know one thing. Is 2 plus 2 still equal 4, or does it equal 4.65? I just want to know. Because I'm going to have a problem with math. So we can basically, if we can put it on the fuse that's going after all the injectors, we can look at the height. We can watch the amperage. And then what can happen is what? If an injector drops off, what should the amperage do? Drop down to a what? Or if we can grab all the signals, we'll see them. And if we lose an injector, what should happen to the hump? Go away. Okay, I got the car running. Toyota, V6, hot. What do I know about this injector right here? Red is injector number 3. The car runs good cold. It gets real hot. I tell you to zoom in the bottom, looking for counter voltage. It's flat. All it tells me is that the driver in the computer was able to take the supply voltage, pull it to ground, and hold it there. What does that tell me? What about number 5? Right next to it. 1 and 5 get all the air. The General Motors, the Hondas, the Toyotas, I always find the middle one in the back. If I got a problem, I usually go there first. And there it's just zoomed up. I got rid of the ignition. Okay, Jeep, intermittent misfire. Yellow is injector supply. Number 2 is injector control is in red. Number 3, green, is the adjacent cylinder. So yellow is a straight line going across, and it's at what kind of voltage? Supply voltage going into the injector. Coming out of the injector, I have 5.5 volts being pulled to ground. First thing I'm thinking of is what kind of voltage drop is where? At the connector. I tighten it up, put stable and 22 on it. I put it back on. I mean, I snapped this thing in problem. I still got the problem. Where is it? It can only be from where? I'm taking it out of the injector. It's the ground side of the injector. It's the injector. It's the injector. It's the injector. I got supply voltage coming in. I have a voltage drop inside that injector. It's not at the terminals. I would have bet it was micro-threading at the terminals. Micro-threading is when all the vibration, we start to have a terminal tension issue. A lot of times if you pull it off, and I get a misfiring cylinder, and I slide it back on, and my problem goes away, what did I do when I slid it back on? I cleaned the connection. I cleaned the connection. Ignition. I'm missing one. That's what I like about a scope. I'm missing one. Ford is famous for this. Now look at this. Another Ford. Channel 1 is yellow. It's ignition on the adjacent cylinder. Channel 2 is in red. This is a different car. Channel 2 is ignition control. Channel 3 is the cam sensor down the bottom, green. So yellow is an ignition or another cylinder. Red is the cylinder that we're having the issue with. And then there's the cam sensor. I'm going to take out the other cylinder. What do we have here? We have the supply voltage being pulled down to what? Is it ever going to ground? And then it's releasing and coming back. And it's literally just holding. It's really not doing its job. Really not doing its job. After 2005, 2006, the Ford coils are pretty good. I have issues between 2000 and up to like 2004. The cars come in, and they're running. I can't even keep them running. And I go, dude, there's no way she drove it in. What do they do? I got shorted coils. And during testing, what's he doing? And what's he doing to the drivers? He's taking them all out. The new drivers, they seem like they're, I call them smart drivers. They just, a lot of times, if they draw too much amperage, they pull right back. Pull right back, shut right off. I don't see that so much on the old ones. The new ones, they're also a lot harder to get signals out of them because of the way they're insulated. We're trying to keep the EMI down. Coils produce a lot of EMI. But the later ones, it just seems like the problem. So the low side driver in the PCM's got a problem. Again, I'm looking at the control side. I'm not even pulling the coil out. If it looks like that, can the coil actually work? If the driver's doing that, am I going to leave the component in the car? No. No. Yank it out of the car. Look at this. Intermittent misfire, then it stalls out. The red, sorry about this, I took this off my laptop. The red is the cam signal. The yellow is the ignition control. Right here, let me hit the contrast. Yeah, do it later. Right here, the car's idling. Right? I'm outside the car. Right here, we got spaces between. We're idling about 700. What happened right here? The frequency get lost. The frequency included, right? It ramped up. I'm not touching the gas. So if PCM thinks that engine's going 10,000 RPMs, what's it going to do to the ignition? And the coils, it's going to fire, fire, fire. We're working on the car, it does this. So I have the guy pull it out, I said, look, change all the plugs, it's soaked. So then he turns around, it did this again. I knew the plugs were soaked. I said, now we got to go to the cam sensor. And we're going to check all 3 leads and see if it's doing it itself or is the PCM doing it. So I go, all right, dude, we got to take these plugs off. One more time, the cam sensor's bad. You do the plugs on one side, I'll do the plugs on the other. He's on the other side, he goes, hey, I have to use a pry bar. Pull a coil out? So he's over there pulling. I go, dude, what are you doing? Then he comes out and he's looking underneath. He pulls out a longer bar. He's pulling. I go, coils come out like this. Oh, yeah? It exploded. The aluminum came out and welded itself to the spark plug tube. It loaded up with so much fuel, and bam, 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 bam. Did that overheat? Was there any time for that coil to cool down? That coil was firing like it was going 10,000 RPM. It just exploded. Just totally exploded. Okay, again, concentrate on locating the root cause of the problem each time. Perform the basic test. Do not be led by others. Let your test lead you. Stay focused. Take good notes. When you replace a defective component, test it. Do not second guess yourself. And start looking elsewhere for the root cause. Here's my garbage in, garbage out. Again, these are my 4 primary circuits. I'm not saying primary inputs or outputs. Those are my 4 primary circuits. Now I want to do one more thing. He said I got 10 minutes. I got 12. They ordered Chinese food. It tastes like crap. I already tasted it, so. She bought Chinese food from Walmart, so. I just want to hit this real quick. I just want to give a couple more case study. Oh, here's a 2005 Avero. This is funny. Misfires under load. It does. Crank sensor schematic and waveform. I just took a picture of the crank sensor. This is a Hall. They put 2 crank sensors in it. It's a Hall effect switch, 3-wire Hall effect switch that sends an AC signal to the PCM. Here it is. And I got 3,000 RPMs, idle 3,000 RPMs. It goes basically total of about 1.5 volts. Is that a problem? Now, to make that sine wave grow, air gap, speed of it, and the strength of what? The magnet. So the magnet strength can also be what? The wiring. Bad ground. Fix the ground, snap the throttle, fixed. I got 6 volts going up, and I didn't even clean it up. I got 6 volts going up, almost 6.5, and I got 5 going down, 4.5 going down. Fixed. The wiring, you got to stick with the wiring. Just an odd thing. It was weird. Mark's Ranger. We can check this out. He must have bought it from Snappy. Mark's Ranger. We put this on. Customer came in, we had to do a misfire. It's got 200, 300,000 miles on it. Car comes in, it's misfiring. Ignition's leaking, we find a low cylinder. Customer don't want to fix the truck, but he wants to make it run a little better. We put this on. Now we have a stalling issue. It's stalling, PCM resets, stalling, PCM resets. This is what we got. It's in every signal. This tool was taking the secondary and putting on 24 circuits on the PCM. It was, what happens with high voltage? It resets the PCM. That's what it did. Okay, look at this. That was that Solara. I just cleaned up the signal. High, low, high, low, high, low, high, low. What's wrong with that car? One bank is what? Time is off, one bank. Okay, misfiring relative compression test. Look at this. The guy comes up, he says, Dave, I got $500. He's a big shop, they track all their time. $500 in diagnostic time. I crank it over, what's wrong with this car? Watch this. So you get the sink, you line up the sink. Watch this. I put air in the hole, that's my crankcase. Boom, right off the shop. What's leaking? Rings and springs. Restricted exhaust. Again, it should flatten out right about here. If it looks like this, see how it looks like the snap's going up. See how it looks like a running compression? Looks like it's got a valve timing. You can see the valve timing and whatnot. That's restricted exhaust. Also, one other thing. If you take the bottom of this, if you take the bottom opening, I can't find that thing, and you put a line across here, and here's 60 degrees. Put a cursor at 60 degrees. Then find the highest point. Move the cursor over to the highest point. Here's the highest point. Then take your vertical cursors, go from the bottom here to the highest point. Anything over 8 to 10 psi is restricted exhaust. Hell, that looks like a running compression. That's a snap. That line should be fairly straight. So right here, it's at 15 and it's going up to 29. Restricted exhaust? Is it more than 8? More than 10? Yeah. Oh, look at this. Again, I just want to use a current ramp. Just using different things in your box. $100 current ramp. When it's hot, this is what happens. Injectors, all the injectors are up in red. Number 1 coil is on blue. What happened? Look at the, I got, where the hell is that thing? I need a snap thing. Oh, there it is. Looks like a pen. Drives me nuts. Okay? We got this fires. 1, 2, 3, 4 fires. 1, 2, 3, 4. Right? So we got intermittent misfire when it's hot. 1, 2, 3, 4. 1, 2, 3, what? Then look at this. What happens? It took about a minute of doing this. What happened? Problem came back. I put on a scope and I'm just looking at it. I'm recording the data. I'm working on another car and I hear it missing. Come over and I stop it. I catch this whole thing. You just can't do that on a scan tool. I know guys love scan tools. And there it is fixed. Oh, one last thing. This is VVT. Everybody drives crazy with VVT. John just did a great class on VVT vision. Okay, this is a condition of the vehicle when I showed up the shop. They took the whole front, the top off, the valve. That don't mean nothing to me. Put it back together. This is it again, marked everything. Don't mean nothing. Put it back together. Okay, vehicle's equipped with a 5.7. It's got 40,000 miles on it. Engine runs rough. Mill lights on. Misfire failed test stored. 1, 3, and 5. Verified rough running condition. It doesn't have 7, but shouldn't 7 be on there? Okay. Verified rough running condition. I haven't put it all back together. When this motor, after it gets hot, you can't touch it. It's a V8, it's a Hemi, a big V8 in a Toyota. You got no room. I bring it back. I said to the manager, dude, I bring it up at 3,000. I put a load on. The misfire's gone. He goes, misfires don't go away. They get worse. I go, dude, it's gone. I'm telling you, I think it's a cam problem. Well, we had it all apart. We marked it. We think it's right on. I don't want you to take it apart. I go, it's a cam problem. I show up the next day. The car's apart again. Put it back together. So I put it back together. I check everything, do all my basics. Again, I got to check my basics. The bank 1 power supply and the coil's the same. You know, possible we have a severe vacuum leak. I'm just thinking of things in my head. But what can we do real quickly to rule this thing out? We'll put a pressure transducer in number 1. While we're there, we're going to test the output. And we'll check the injector and the ignition timer right at the same time. We can do that all. Then we'll install the cylinder across because we're not having any problem in the opposite bank. And we'll look at the comparison. Here's a good one. Now, we know right here, the exhaust, it's got multi-valve, it's a new one, it's got 4 cans of VVT, so we're allowed at 15 degrees this way. So that's okay. The intake should be 20 to 30 degrees after top dead center. It's over here. So the exhaust is okay, but the intake is advanced. So when I load the car up, what am I doing with the opposite cam? I'm bringing it up in advance, and the airflow is now the same. I had to wear these during class. I told the guys, I go, dude, I wear those all the time. First year, I go, I can see you give me gestures, so. Okay, now so we got advanced intake cam only. That's where it belongs, that's where it is. I go to the other side, it's right on. Now, I got a chain that goes from this to that one back to the crank. This cam is off, but the exhaust right next to it is right on, and the other side's right on. What's the chance, 40,000 miles, and it had work, they did intakes and all this stuff, what's the chance that chain being off? No, I just don't believe it is. So, could this be a time and chain correlation issue between the intake cam and the exhaust? No, they're side by side. They're so close you can't even move the chain. If so, would this correct itself under medium heavy load? No, the problem would still be there. Could this be a variable valve timing issue with the bank 1 intake cam? How can we verify that the VVT is being the cause of the misfire? We do what? Disable it. That's what I'm saying. This thing got worked on for weeks. So if I think that the computer or something's on the car holding it advanced, what do I need to do? I unplug it. I unplug it, it goes back to the rest position. The problem's gone. Rev it up to 3,000, now I got a misfire on that bank. Why? It's disconnected. There can only be 2 problems with this thing. What are they? PCM is doing it, or what? The wiring. They did the intake, they did exhaust gaskets. They laid the harness on the manifold. Real quickly. And look at this, VVT, no PIDs. 2007, no PIDs. And I talked to Mike McCarthy, I said, Mike, those should be populated. So we can check them real quick. There they are right there. Only disconnected. Check everything. Look at this. Oh, you can't see it. I get both of them. The minute you start it, when it's ice cold, then look at it, and then look at it. Short it on the manifold. But I said, let's keep it simple. If I think it's being held on, what do I do? If I disconnect and it's still there, could the solenoid be stuck? If I take it off, I'm going to add power to it. It should do what? Click, 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 right? If I take the solenoid off, crank it over, the oil should spit like over my head, hit the hood, right? Hit the fender. I think if it hits the hood, hits the floor, and then hits the wall, that's got to be 50 PSI, right? Maybe 48? Okay, so I'm just saying, so simply we can really check this. Just keep it. Do I care about the VVT? Do I care about the, I don't care about the, I care about the combustion process. That's all I want you to do. Guys, thank you.